So what exactly is the meaning of magic square? This is a question from CAT 2017, right? Magic square are generally those square where the summation of the numbers row wise, column wise and diagonal wise should be same. And that matrix can be a 3 into 3 matrix, can be a 4 into 4 matrix, can be a 5 into 5 matrix, can be a 6 into 6 matrix also, right? So in any n into n matrix, the summation of all the numbers row wise, column wise and diagonal wise should be same. Now look at this question. The question says, the question from CAT 2017, the number 1, 2, 3, 4, 5, 6, 7, 8, 9 are arranged in a 3 into 3 square matrix in such a way that each number occurs once. That means you are not supposed to use the number twice. Every number will be used once. And we know that in a 3 into 3 matrix, there are total 9 cells. 3 into 3, total number of cells will be 9. And the question says these numbers are used in this 3 into 3 matrix in such a way that entries entries along each column, each row and each of the two diagonals add up to the same value. That means if I add all the three numbers here, the value that I'll be getting here should be same if I add all three numbers of the second row, should be same as all three numbers of the third row, should be same as all three number of the column 1, column 2, column 3 and diagonal 1 and diagonal 2. Now, the main concept here is you're supposed to know what are the numbers that you're using. You're using the number 1 to 9. Now you see that if I'm writing down all the number into a 3 into 3 matrix and if I add the total, if I take the sum of all the values, then you see the total summation of that value, will be equal to 45. Why it's so? Because sum of first 9 natural number is 45. Right? If I used all the numbers from 1 to 9 and if I write down it into a 3 into 3 matrix, the summation of all these numbers will come out to be n into n plus 1 by 2. This is a concept of sum of first 9 natural number. Putting the value of 9 here, the total summation will come out to be 45. Now, if the total value comes out to be 45, you see that every row has the same number, every row adds up to the same value. That means this total value of 45 is equally divided among these three rows. So that means the total of every row has to be 15. Now this is where you should start solving this question from, right? This is the first step that you need to take whenever you are solving a magic scale. This question is a very basic question, right? But we'll first try to understand the concept and then I will discuss the advanced level questions also. But if you talk about the level of difficulty of CAT, this is what they are asking, right? The level of difficulty is not high. It's a very simple one, right? So the total, right? You need to know what are the total numbers you are using, divide it equally among three parts. Every row will be having a value of 15. Every column will be having a value of 15 and every diagonal will have a value of 15. The summation of the numbers in the diagonal should also be equal to 15. Now, if this number is 6, this number is 2, the total is 15. So can I say that number has to be 7 here? Now, there's some tricks that you can use. Ki middle mein 5 aayega, right? If you can just keep this in mind. But I don't want you to cram any of this thing. Let's reach to this conclusion. Which number will come in the middle, right? So whenever you're solving a matrix, try to fill in the middle number. The moment you find the middle number, it becomes very easy for you to fill the complete matrix. So in the first step, right? Once you take this step, what will be the summation of rows and column? The next target should be to find out the value here, which will come in the middle. Now let's find out how will you find this value? See that. I want the total sum to be 15, okay? So if the total sum is to be 15, let's just for example, I'm writing down the number A here, writing down the number B here, C here, right? D here and E here, right? And we are supposed to find out these values. Now I want the summation of the diagonals to be 15. The value is 2 here. A plus B has to be 13, right? A plus B has to be 13, okay? I want this to be 15 also. So can I say a plus x also should be this number is 7, so a plus x has to be 8. Now just try to see the options here. Let's find out what are the combination of two numbers which will give us the summation as 13 or the summation as equal to 8. Okay. We have already used the number 6, 2 and 7. So these numbers are not available to us, right? Now if I write down all the numbers, 1, right, 2, 3, 4, 5, 6, 7, 8 and 9. 6 has been used, it's not available to us. 7 has been used, it's not available to us. 2 has been used, it's not available to us. I can tell you the shortcut trick of solving this question, but I want you to understand the process, because this shortcut might not be applied to the questions that you will be coming across in the next CAT exams, right? They might ask you a question on a different concept. So you need to know the concept behind it, right? Or cramming the shortcut tricks will not be helpful in every type of questions of metrics, right? So therefore, just let's understand the basic concept and the process of it. Okay, now. So we see that, now you see that I need the summation of these two values to be equal to 8. The combination possible is 3 plus 5. This is the only possible combination. No other combination is possible. A plus x needs to be 8. For two different numbers, 3 and 5 is the only possible combination. I cannot take 1 and 8, right? 1 and 8 is 9. 4 plus 4 is not possible because we are not supposed to use a one number twice. So 3 plus 5 is the only possible combination. Once you know 3 plus 5 is the only possible combination, you take the possible cases that either 3 will come here or 5 will come here. Now, if I apply the number 3 here, if I take the number 3 here, 3 plus 2, 5, 5, and to make this diagonal 15, I need to take 10 here. Is it possible? No. I'm supposed to use the number from 1 to 9. So 3 is not possible here. So 10 is not possible here. If 3 and 10 are not coming here, that means the only possibility for A is 5. Now if this is 5, right? If this is 5, then 7, 5 plus 2, 7, 7 plus 8. Then this has to be 8. 8 plus 6, 14. This has to be 1. 5 plus 1, 6. This has to be 9. 9 plus 2, 11. This has to be 4. 5 plus 7, 12. This has to be 3. So we are supposed to find out the value of x. So the answer to the question is 3. Right? This is a CAT 2017 question, a very basic one, right? But this is a standard concept, right? I choose this question to explain the concept of magic squares, right? That magic squares are those squares with the summation row-wise, column-wise, diagonal-wise should be same. And you need to understand the process while you are solving the magic squares, right? So this is a basic one. This is a basic one. I'll be discussing we will be discussing the complete series of magic square questions. There will be around 7 to 8 videos I'll be uploading on magic square. This is the first one just to explain the concept of magic square, to make you understand what exactly is the meaning of the magic square, what are the different type of questions that the examiner can ask from the concept of magic square or from the matrix, right? It doesn't mean that every time this statement will be given whenever you are solving a question of magic square, that the summation of all these rows, column are same. Condition can be changed also, right? Examiner can say that the summation of row 1 is same as the summation of row 3. You will not call that magic square, but yes, the concept of solving those type of set will also be similar to this one, that we are supposed to take the cases and use the information given here. For example, in this particular case, the catch point was the summation of every row and every column should be same. This is where you should be starting the questions from, right? If you know this, the total will be 45 and every value will be equal to 50. You can easily solve the question. If you don't know the first step, you will never be able to solve it, right? ये 17 में question आया था. 2018 there were 4 questions of in data interpretation based on the concept of matrix, not exactly of magic squares, but yes, it was of magic. It was of a matrix based set. It was based on the concept of matrix, which we will be solving in the upcoming videos. But let's first understand the concept and the questions related to the magic squares, and whatever number of questions we have for matrix, we will be solving in this complete playlist. Thank you so much for watching the video, and I'll be uploading more videos on matrix. So see you then in the next part of the video. Subscribe to the channel, share it with all of your friends. Thank you so much. Hello everyone, welcome back. So in this video, we will be solving one more magic square set, a very small set, just to give you the idea how to approach these type of question. And there is a slight change in this particular question. The question says, we are supposed to fill this n into n matrix, that is 3 into 3 matrix, the numbers between 1 and 12, including the extreme position numbers. Now, number between 1 and 12, including the extreme position number, that means 1 and 12, the total numbers are 12, right? So these 12 numbers are supposed to be filled into a 3 into 3 matrix. Now the problem is, in a 3 into 3 matrix, the total number of cells that you have is 9. Numbers that you're supposed to fill is 12, right? When you read it further, it says that not every number is supposed to be used, right? It doesn't mean that every number from 1 and 12 has to be filled here. You're supposed to select 9 numbers out of these 12 numbers to be filled in a 3 into 3 square grid in such a way that each number occur once and the entries along each column, each row and each of the 2 diagonals add up to the same value as 24. The summation should be 24. Now what number out of these 12 numbers we are supposed to use? What 9 numbers out of 12, right? The total numbers are given 12 and we are supposed to use only 9 out of those 12, right? Those 9 numbers can be any numbers, right? But the summation of these numbers should add up to value as 24. Not every number will be used. No, it's not compulsory that every number from 1 to 12 has to be used. You may use each number only once, complete the grid. We are supposed to complete the grid. Okay. Direct information can be used. The summation has to be 24. So if this is 7, this is 6. Can I say this number will be 11? Very easy. Only then the summation can be equal to 24. Now, I also need the summation here as 24. Here as 24, right? I also need the summation in the column wise 24, right? And it should be the diagonal. The summation of the diagonal should also be 24. The summation of the diagonal here should also be 24, right? As I told you in the previous video, that your target should be to find out this number, because the moment you find this number, you will find this number because you know the sum is 24. The moment you find this number, using this diagonal, you will also find this number. And the moment you find this number, using the diagonal sum, you can find out this number. Now, once you know this number, this number, this particular cell number, this particular cell, everything will be find out. If you can find out what will be the number which will come in the middle, right? So this cell is our target, right? यही cell को आपको सबसे पहले target करना है. So let's see. Let's assume this number is A, this number is B, right? This number is C and this number is D. Let's use it now. Let's use the concept. If this number is 6, can I say that A plus B, right here, this number is B, right? A plus B will be equal to 18, right? A plus C will be equal to what? If A plus B is 18, right? A plus C, this number is 7, so A plus C has to be 17, okay? And you see that A plus D here should be equal to 13. Now you see that number A has to be same in all these three, right? And that number A when added to B give you 18. The number A when added to C give you 17. The number A when added to D will give you a number 13. Now let's see what that number could be using these three equations. Now we have the numbers from 1 to 12, right? Just to explain you, let's write down all the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? I already used number 6, 7 and 11. So 6, 7 and 11 has already been used. So these numbers are not available to me. Now look for some combination here. A same number A added to B give you 18. Now tell me which number can give you the summation as 18 here. You see that there is only one possible combination. 1 plus 17 will be 18. 17 is not available to us. 2 plus 16 will be 18. 3 plus 15 will be 18. 15 is not available to us. 4 plus 14 will be 18. 14 is not available to us. 5 plus 13 will be 18. 13 is not available to us. We are reduced down to only one possibility. If I need the summation to be 18, that number has to be 8 and 10. Only 8 plus 10 can give you 18. Now, A can be 8, B can be 10, is a one possible case, or A can be 10, B can be 8, there's a one possible combination. Now let's see how A plus C can be 17. If I take 8, right, if I take A as 8, then C need to be 9, 9 is available to us. If I take A as 10, then C has to be 7, 7 is not available to us. 7 is not available to us, right? 7 has already been used. So this is a possibility which is out of the option. So you get to know A is 8 now. So A plus D is 13. So 8 plus 5 is 13. You see that 8 is the possible values which when added to 10 give you 18, which when added to C 9 give you 17, which when added to 5 give you 13. Now let's use it, guys. Let's use it. If I take A here as 8, you'll get everything, right? 8 plus 6, 14. I need the summation of, yes, 8 plus 6 is 14. I need A plus B to be 18. Now if A is 8, B is 10, right? Okay. Now you see 8 plus 7 is 15. 15 plus 9 is 24, right? And what else we are left with? 10 plus 9, 18. D will be 5. 7 plus 5, 12. 12 plus 12, 24. 12 plus 8, 20. 20 plus 4, 24. That's it. The grid is completed now. And these are the numbers that we are supposed to use. Now, whatever question the examiner is asking you, which number will come in this cell, which number will come in this cell, you can easily answer the question, right? So I hope through these two sets that I have discussed with you, you get the basic idea how to solve the magic square, how to approach the magic square based questions, right? These were two very, very basic questions. In the next video, we will be discussing one advanced level magic square based concept set, which is a very advanced level, exactly relevant to CAT, not that high level, right? But it says the concept is quite tricky. Cases are so many. You are supposed to, reduce down to, you should know how to reduce down to one single case, right? How to eliminate the number of different cases, right? Which particular case you are supposed to pick, right? So this is what the next set will be all about. So watch these two sets, try to solve these two sets again. Only then the actual concept of matrix will be fit in your mind, and then you will be able to solve advanced level question, which we will be solving in the next video. Now look at the set here that we are supposed to discuss. It says the diagram is a magic square in which all rows and columns and both diagonals add up to 38. No number has been used twice. Find PQ. So we have this magic square, and in this magic square all the values, right, row wise, column wise, row wise should add up to 38. For example, here you can check 15 plus 2 17 plus 5 22 plus 16 is 38. 2 plus 9 11 plus 14 25 plus 13 38, right? So similarly, some of these values are missing. We do not know what are these values, and using this condition that the diagonal sum, row wise sum and the column wise sum, row wise sum and the column wise sum should be equal to 38, then what should be the value of P and Q? All right. So how you should be approaching it? See that the point here is that the total summation should be equal to 38. This is the point that you need to catch. You see that here, if I am looking for this value, this is 5, this is 17. 22, to meet the condition of the summation of the row wise summation to be 38, can I say that the value of P plus Q has to be equal to 16? Because if P and Q will be 16, right, only then this whole row summation will be equal to 38. And then you see that diagonal sum should also be equal to 38. This is 16, this is 13, that is 29. So whichever number that will come over here, the summation of these two cells should also be 38. So can I say this is A? So 16 plus 13, 29. Can I say that the value of P plus A has to be 9? Now the summation of two digit is 9, and one more thing that you are supposed to keep in your mind is that the no number has been used twice. What does it mean? If a particular number 2 has been used here, this number cannot be used twice. It has to be used at the same cell here. 15 cannot be used twice, 5 cannot be used twice, 16 cannot be used twice. These digits have already been used, so you cannot use these digits. Okay, now let's see that what are the possible combination for P plus A to be equal to 9? How can you make the summation of two digits to be equal to 9? If I take P as 1, right, the first possible combination is P is 1, A is 8. Now you see that if I am taking P as 1, in that case Q has to be 15 because P plus Q has been 16. But then Q cannot be equal to 15 because 15 has already been used. So can I say P plus A being 9, 1 plus 8 is out of the option. You cannot take P and A to be 1 plus 8. The next possible combination is to take 2 plus 7. Will it work? See that P cannot be 2 because 2 has already been used. So straight away you can eliminate this option also. What if I use it as 3 plus 6? If I take P as 3,
in that case Q will be 13 and 13 has already been used, so this is also eliminated. If I take P as 4, in that case A has to be 5. Now if I take P as 4, Q will be 12. Okay, 4 has not been used yet and Q as 12 has also not been used yet. So there's a possible combination. This might work, but this is the only possibility. We do not know that. This is a possible combination here, that if I'm taking P as 4, Q, A will be 5. Let's try to use it. If I take P as 4, A will be 5, right? 4 plus 5, 9. And then I need to make sure that P plus Q will be 16. So Q has to be 12. Okay. Now you see that 14 plus 5, 19, 19 plus 17 would be 36, 36 plus 2 would be 38. Now what is the problem here? 2 is being used twice, 2 cannot be used twice, so therefore this option is also eliminated. 4 and 5 is not the options that you can use. P cannot be 4, A cannot be 5, because in that case you'll have to put 2 here to meet the condition that the summation should be 38, and 2 will be used twice then, so 2 will be, this case will not work. Then the next possibility is that if you take P as 5 and in that case A will be 4. 5 anyway you cannot use, right? 5 has already been used. So we could have, would have eliminated the option 5 straight away. I missed it, that 5 has already been used here. So 5 is out of the option. P can be then 6. In that case A would be 3. Now if I say P is 6, A has to be 10. Now this might work. If I am taking P as 6, A in that case will be 3. Okay. P plus A has to be 9. 16 plus 6, 22 plus 3, 25 plus 13, 38. If P is 6, A has to be equal to 3 here. Now A is 3, right? Now in this case you see that if P is 6, then I'll have to use Q as 10. In that case Q will be 10, right? And 14 plus 3, 17, 17 plus 17 is 34 plus 4. So this value will be 4. You see that now all these digits which I am getting 6, 3, 10, 4, these are the new digits. They have not been used anywhere in the matrix. So this is a possible combination here, right? This might work. If I go for the next option, 7 plus 2. You see that if I take P as 7, then Q will be 2. 2 has already been used, so eliminate it. If I take P as 8, in that case A would be 1, right? If P is taken as 8, in that case Q will also be 8. Now both of these two will be same, so this will also not work. So see that all of the combination, in all of the combination, there is only one combination that is working. It is P has to be 6, A has to be 3. In that case, Q has to be 10. This is the only possible combination, right? So if there is a matrix that exists with the condition where no digit is being used twice in the matrix and the summation of rows and columns should be 38, the only possible combination for P and Q has to be 10. Do I need to find the rest of the digits? It's not necessary, because if we would have two options, right, and if we would have to verify which of these two options will work, which of these two cases will work, then we might have to complete the matrix. But here we are getting only a unique case. Only possibilities for P and Q is to be 6 and 10. So that's why you can straight away answer the question as 6 into 10, that is equal to 60. So 60 would be the answer of this question.
So in this video, we are going to cover advanced level set of magic scare. The concept, the basic concept of magic scare, the meaning of the word magic scare has been covered in the previous two videos. And here is this set that I want to discuss with you in this particular video. It's a bit advanced level, right? But this will clear all your concepts of magic scare. And once you do this exercise, you will start feeling comfortable whenever you're solving a 4 into 4 scare matrix or a question which is based on the concept of magic scare. Let's read it through. The question says 16 consecutive natural numbers to be filled into a 4 into 4 scare matrix. So we have this 4 into 4 scare matrix. So total number of cells you can see are 4 into 4, that is 16, and we are supposed to fill 16 natural number in this 4 into 4 scare matrix, such that there is one number in each box of the matrix. Every cell should be filled with one number. Not necessarily in any order. There's no order which is given here, there's no fixed order. The numbers are filled in the boxes in such a way that the sum of the numbers in the boxes of any row, any column, and any diagonal of the scale matrix is the same. Now, Again, the definition, this is a definition of magic square, that the summation of the number row wise, column wise and diagonal wise should be same, and this is mentioned over here. But what is that sum? We do not know that. We could have found the sum if we know what is the lowest number that has been used here and what is the highest number that has been used here. अगर हम इस स्क्वायर मैट्रिक्स के अंदर लोवेस्ट नंबर हमने जो यूज किया और हाईएस्ट नंबर जो हमने यूज किया, बिकॉज क्वेश्चन सेज 16 कंसेक्यूटिव नेचुरल नंबर, 16 कंसेक्यूटिव नेचुरल नंबर यूज हुए हैं, लेकिन कहाँ से स्टार्ट हुए हैं? 1 से स्टार्ट हुए हैं, 5 से स्टार्ट हुए हैं, 10 से स्टार्ट हुए हैं, 17 से स्टार्ट हुए हैं. वी डू नॉट नो दैट, राइट? सो सबमिशन तो हमें तभी पता लगेगा जब हमें ये पता लगे कि कौन से 16 नेचुरल नंबर्स हमने यूज किया. व्हाट आर द 16 नेचुरल नंबर्स दैट वी आर यूजिंग हियर, right? So that we get to know what will be the sum row wise and what will be the sum column wise, right? It has to be same. But for that we need the lowest and the highest number. Okay. But you start underlining those important information which are mentioned here. जितने भी important points हैं, अगर आप उनको underline नहीं करते, mind में नहीं रखते, then you will never get an idea where you should be starting the set from. So now, but the important word here is the numbers are consecutive, right? So consecutive natural numbers, underline it, okay? The numbers are filled in the boxes, okay? We have read it through. The cell number are denoted by 16 alphabets, namely A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, right? So A to P alphabets are basically representing the numbers here. The value in the cell A is the least value. This value is the least one. This value is the least value among all, and it's a 2-digit prime number. This number is a 2-digit prime number. This is a 2-digit prime number. It's a 2-digit prime number, right? A is a 2-digit prime number. The value in the cell D, is a 2-digit perfect square. This number is a perfect square. Now, this is basically checking the knowledge of number classification, whether you know the definition of prime number, perfect square and all these, right? So you should be good with the classification of the numbers chapter, which we study, which we used to study in the first part of the number system, right? So D is a perfect square. What else we have here? The value in the cell A is the least value among all, right? So A is the least value among all. It's a 2-digit prime number. The value in the cell D is a 2-digit perfect square. The sum of the value of A and D is a prime number less than 45. You see that? Now there's one more information. A plus D should be 45. Right? The value of A and D is a prime number, sorry, not 45. The value of A plus D is a prime number, and this prime number should be less than 45. Now let's look at the possibilities. Do we have anything else related to A and D? Let's read it through. The sum of the value of F, G and K is 60, not related to A and D. What we need is something related to A and D. The value of M is a perfect square greater than the value of the cell D. Okay, M is a perfect square. This value is a perfect square, but it's mentioned as a perfect square which is greater than a value of D, right? Okay. The value of the cell P is the highest among the whole matrix. This number is the highest, right? This number is the highest number. Now, let's find out these corner values, because every statement is talking about these corner values. Let's start. So tell me, what is the least 2-digit prime number? A should be a least 2-digit. A is the least value among all and it's a 2-digit prime number. Let's find out what are the 2-digit prime number. The first 2-digit prime number is 11. Okay. The next 2-digit prime number is 13. The next 2-digit prime number is 17, and then we have 19, then we have 23, okay, and then we have 29, right, 31, right, and then I have 37, and then I have 41, right. I don't need to go above 41 because summation of these two values has to be a prime number less than 45. It has to be a prime number less than 45. So no point of taking value which is above 41. So A is 11 here, right? So now tell me, D is a perfect square, right? D is a 2-digit perfect square. It's a 2-digit perfect square. Which number is a 2-digit perfect square, right? And both of them should result into a prime number that is less than 45. You see that 2-digit perfect number is the first 2-digit perfect number is 16. Will 16 work here? 16 plus 11 is 27. It will not work. Next perfect square is 25. 25 plus 11 is 36, right? It's not a prime number, right? The summation of these two should result into a prime number. Next perfect square is 36. 36 plus 11 is 47, but that number is greater than 45. So can I eliminate this case? Right? There is no possible combination of A and D where the summation of the values give us the summation of this prime number and this perfect square give us another prime number less than 45. So therefore this case is eliminated. Look at this case, 13. 13 plus 16 is 29. So you see that this is a valid case, right? But there can be the multiple cases. 13 plus 16 is a 29, which is again a perfect square. Any other possibility? Okay, 13 plus 25 is 38, not a prime number. 13 plus 36 is 49, again a value which is more than 45, so eliminated. This is also eliminated. Let's go with 17. 17 plus first perfect square 16 is 33, eliminated, right? 16 will not work. Next is 25. 25 plus 25, 17 plus 25 is 42. 42 is not a prime number, right? So this is eliminated. No point to move to 36 because 17 plus 36 will be more than 45. This case eliminated. 19 plus 16, 35, not a prime number. Okay, eliminated. 19 plus 25, 44, not a prime number, eliminated. No point to take 36, number will be more than 45. This case is eliminated. 23 plus, tell me the number. 23 plus 16 is 39, right? Not a perfect square, 23 plus 25 will be more than 45, eliminated. 29 plus 16 is 45 itself, eliminated, right? Not a prime number, and we are looking for a number which is less than 45 and should be prime number. 31 plus 16 is more than 45. All these cases will be eliminated, right? So there's only one case that is working, that A plus D, right? The value of A has to be 13, the value of D has to be 16. The summation will come out to be equal to 29, which is a prime number. So now you see that we got the value of A, we got the value of D. Now let's write it down. A is 13, right? A is 13. Let's write it down. The value of A is 13 here. D is 16 here. The value of D is 16 here. Now M is a perfect square. Now it was also mentioned that A is a least number. A is a least number. Now you see that if I'm saying that A is a least number, then there's 16 consecutive natural number and P is a highest number. Then what should be the value of P? P is a highest number. What should be the value of P? You see that I'm writing down 16 consecutive numbers. So can I say if I'm writing starting from 13th, the 16th number will be 28. 16th number will be 28. And P has to be that number because P is the highest number. So therefore, the value of P will be equal to 28. Value of P will be 28. Now, M is a perfect square also. Question says, M is a perfect square greater than the value of the cell D. M is also a perfect square, but it need to be greater than 16. So what is the possible value for M? If M is a value greater than D and it's a perfect square, that means can I say M has to be 25. M has to be a number which should be a perfect square greater than 16 but less than 28. So the only possible value for M has to be 25. You see that? Now we got 4 values, 13, 16, 28 and 25. It's also mentioned. Now you see that. Now you can apply the concept of the magic square. And what is that concept? That once you know what are the 16 numbers that are being used here, you can find the total sum of all the complete matrix, and that total sum can now be divided equally among all the rows and columns because the summation of the values of all the rows and the column are same. So therefore, now find out what will be the summation of all these 16 numbers starting from 13 and ending at 28. Here you need to apply the concept of arithmetic progression. The summation of arithmetic progression is represented as n by 2 into A plus L. A is a first term, L is a last term. Number of terms are 16 divided by 2. The first term is 13 and the last term is 28. Right? So 16 by 2, 8 multiplied by 13 plus 28 is 41, and the total summation will be 328. The total summation, right? This is the summation of all these values. Now, if I'm saying that the sum of all the values row wise and column wise are same, I need to divide 328 equally among all the four parts. So you get to know the total summation of row wise should be 81, right? So that means the summation of all these value has to be 81. Summation of all these value has to be 81. Sorry, not 81, I'm sorry. 328 by 4 will be 82, right? 328 by 4 will be 82. So it has to be 82, right? So this value will be 82, right? So let's write it down. This is 82, this is 82, this is 82, and this is also 82. Column wise, this summation should be 82, this has to be 82, this has to be 82, this has to be 82. Diagonal wise, it should be 82, and this diagonal should also be equal to 82, right? Now let's use our concepts here. There will be multiple cases that you need to work upon, but let's work. Now you see that there's one more information that has been given over here. The summation of the value of f, g and k is 60. The summation of the value of f plus g plus k is 60. Now you see that if this summation f plus g plus k is 60, and I know that total value of this is 82, right? Total value of this is 82. Now you can see that I can use this information directly. And how can I use it? I know that a plus f plus k plus p, a plus f plus k plus p will be equal to 82, right? Where a is 13 and p is 28. So can I say that f plus k, a is 13, p is 28, that is 41. So therefore f plus k will be 41. Therefore f plus k is 41. Now if f plus k is 41, can I put the value of f plus k as 41 here, and I can get the value of g, that will be 19. So therefore this value is 19, and the summation of f plus k here will be equal to 60 minus 19, that is 41, right? This is another equation now we get to know, right? But here I can see the value of g as 19. Now the value of g is 19, 19 plus 16 will be 35, 35 plus 20 will be 60, 60, and this j in that case has to be 22, because this summation also should be equal to 22. So j is 22, right? J is 22. Got it? Now you see that we got 4 plus 2, 6 out of 16 values have been found out. And now the only information, right? We have found all these 6 values. Now the only information that is available to us is the summation of these two has to be, right? I know the total summation is 82, so I can know the summation of these two values. I can know the summation of these 3 values. I can know the summation of these 2 values. I can know the summation of these 2 values. I can know the summation of these 2 values. Is there any other information that can help me in finding a specific value in the matrix? There is no other information that is left. So therefore, I have to go to the multiple cases, right? I'll have to choose the cases. I'll have to make the possible cases which can fit in the matrix and satisfy this condition that the summation has to be 82 here, this summation, and diagonal wise, row wise, and column wise, everything has to be equal to 82. Okay, just to clear the matrix, let me write down all these values in the next slide, right? What we have got till now is that this value is 13, right? And this value is 28, and we got g as 19, right? F plus k is 41, m we have found as 25, right? This value is 16. So we have got these values till now, and this will be j, right? 25, 16 is 41, 41 plus 19 is 60, and this is 22. So these are the values that we know. Now you see that if I look at these two values now, if I look at the combination, I know that these two values f plus k is equal to 41, and if I have to make the cases, there are multiple cases, right? Now you have to look for the number which are greater than 13, less than 28, but the summation is 41. Multiple cases are possible. 14 plus 27 is an option, right? 15 plus 26 is an option. 16 plus 25, a lot of combinations, right? We cannot straight away just keep on writing it down. We need to look for something which is short, right, and which have less number of cases. So which information should that be? You see that 25 plus 28 is 53 here. This value is 53 here. That means the summation of these two values. What are these two values? N and O. What should be the value of N plus O? The value of N plus O, right? 82 minus 53. 82 minus 53 will be what? Subtract 82 from 53 from 82. Let's do that. 82 minus 53, right? Subtract 50, you will be left with 30. 82 minus 50 is 32, and 32 minus 3 is 29. So you see that N plus O has to be 29. N plus O should be 29, right? This is the total value as equal to 29. Okay. Now, if N plus O is 29, what are the possible options I have? The values of two sums should be equal to 29, right? Minimum value should be 13, right? More than 13. So can you see that 14 plus 15 is the only possible combination? So either it will be 14 plus 15 or it will be 15 plus 14. There is no other possibility. There is no other possibility, right? So we can start from there because here we have the less number of cases, right? So either it will be 14, 15 or 15, 14, right? So let's write it down. Either the number will be 14, 15 or it will be 15, 14, okay? Now similarly, let's look at these two options also. 13 plus 16 is 29 and the summation is 82. So the value of B plus C, if I look for the cases for B plus C, right? B plus C, here is 13, here is 16, 29, 82 minus 29. Subtract 30, it would be 52 and add 1, it will be 53. I need the summation of these two values has to be 53. What are the possibilities that I am left with? The summation of two values has to be, see that 28 plus 27 is 56. So if I try to make the cases for 53, it will be very less because the maximum possible sum is 55. So there will be very less number which will give me the summation as 53. What are the numbers that you can think of which will give you 53 between 13 and 28? Between 13 and 28, what are the two numbers which can give you the summation as 53? You see that 26 and 27 is the only possible combination which can give you the summation as 53. So therefore, for these two cells, I have only two possible cases. Either it will be 26 plus 27 or 27 plus 26. So I get to know the numbers will be 26, 27 here or 27, 26 here. Okay. Now we reduce down to two cases now, 14, 15 or 26, 27. Now here we can start making the cases. See that? If I take the number 26 here and if I take, now I have two possibilities here, two possibilities here, right? Two possibilities here, two possibilities here. The possible combination is that I can go with these two cases or I can go with these two cases. So there are total 4 cases. Let's quickly look at the 4 cases. It will not take much time because I just need to add these values. 26 plus 14 is 40. 26 plus 14 is, right? So what I'm doing is I'm just trying to make these cases. I have 27 here, 26 here, 15 here, 14 here. If I'm go with this case, 26 plus 14, 26 plus 14 is 40. 40 plus 59. Okay. If I'm taking this number as 59, I will be left with a number, right? To make it 82, I need to fill it as 23. Can this work? Yes, 23 is available number, right? We can go with 23. This is a possible case. So I'm just writing down a tick mark over here. The 26 and 14 will work. 26 and 14 will work. Okay, what if I choose the option as 27 and 14? You see that 27 and 14, right? If I choose these two, I have checked this case, this is working. Now I'm checking this case. 27 plus 14 is 41. 41 plus 19 is 60. Right? If I go with these two cases, that means if I write down 27 here and 14 here, I will be having the total summation as 60. Now, then I need to write down 22 here, but 22 is not possible because 22 has already been used. So can I eliminate 27 and 14 case? This case cannot work. Okay. Now let's see. What if I choose 27 and 15? 27 and 15 is 42. 42 plus 19 will be 61. Okay. If this is 61, I will be left with 21. I will be left with 21, right? Now, will this work? 61, 27 plus 15 is 42. 42 plus 19 is 61, right, 61, and then I need to take a value of 21 here. That means if I'm taking k as 21, right, this number is k, nothing but this number is k, right? So if I'm taking k as 21, in that case f will be 20. Will this work? Yes, this can work also, right? So this is also again a possible combination. This is again a possible combination, right? So we have this possibility to work. Let's take the another case, right? So 2614 is working, 2715 is also working, right? 2715 is also working. Okay, what if I'm taking 27 and 14 here? Okay, 27 and 14 has already been eliminated. I'm left with only one case, 26 and 15. 26 plus 15, if I'm taking this case as well as this case, 26 plus 15 is 41. 41 plus 19 is 60. 60, then I will be left with 22 to make it 82. 22 has already been used, so this case is also eliminated, right? Now you see that we are reduced down to two cases only, 27, 15, 26 and 14. Now there is one problem with 26 and 14 that we have not checked, that if I'm writing down 26 here, 14 here, 40 plus 19, that is 59, this will be 23. Now if this is 23, that is a value of k. If I'm taking this as 23, in that case f has to be 18, right? 8 plus 3, 11, and 2, 3, 4. So this is also working. So therefore we'll need to make the two cases to do the further elimination. Let's see where will the elimination goes. Let's go with a 2614 case. Let's go with the 2614 case, right? I'm writing down the 26 here. If we do not find any error, that means this would be the correct case, and then we can go ahead with this one, right? So what I'm doing is I'm writing down 26 here, right? And 14 here. So, and this, in that case, this will be 27 then, and this case will be 15 then, right? Okay, this is becoming 82. Now we know that f plus k is 41. 26 plus 14 is 40. 40 plus 19 is 59. I will be left with 23. 59 plus 3 is 62. 62 plus 20, 82, correct? Now if this is 23, this number will be 18. So 18, 23 plus 18 is 41. And 28 plus 13 is also 41. This is working, right? Now, okay, this is perfectly working. Let's check the another case also, right? What if I'm writing 13 here, 26 here, 27 here, right? 16 here. Now I'm changing 26 and 27, right? This is 25, right? This, if I'm writing down 27 here, then I need to write down 15 here, right? 27 plus 15. And this is 19 here, right? Okay, now you see that 27 plus 15 is 42, 42 plus 19 is 61, then this has to be 21. If this is 21, if k is 21, then f has to be 20. If this has to be 20, 15 plus 14, this has to be 14. Now let's see what is the value of j. J is 22 here. Are we getting the sum here as 82? 6 plus 2, 8 plus 4, 12, yes. 2 plus 2, 4, 6, 7, 8, yes. 80. This is becoming 82. This is becoming, everything is working fine. That's perfect, right? So both of these two cases are working. Let me cross check it again. Yes, this is perfect, right? F is also 28 here. F is 28 here. Okay. All right. Okay. Now you see that this number is 20, this number is 19, this is 49. Now let's look for the possibilities of these two numbers. Let's look for the possibilities of these two numbers. What are these numbers? Right, I have 13, 27, 26 here, right? This is 13, this is 25, that is 20, that makes it 38. So I'll be left with 38 of 82 minus 38, 12 minus 8, 4, 7 minus 44. I need the summation of these two values as 44. And what are the numbers I am left with? I have used 13, 14, 15, 16. The numbers which are available to me are now 17, 18 has been used, 19 has been used, 20. In this particular case, I will be left with 20 and 21 is left, 22 has been used, 23 has been used, 24 is the number that I'm left with, right? So these are the numbers I've left with. Now tell me the two numbers where the summation has to be 44. These are the numbers 20 and 24. So I need to use 20 and 24 here. In this particular case, I need to use 20 and 24 here. And then the remaining numbers, which are 17 and 21, has to be used here. What case will work so that the summation here comes out to be 82? 18 plus 19 is 37. 82 minus 37. If I subtract 37 from 82, I'll be left with 45. So if these are 37 and I need the sum as 45 here, in that case, I'll be taking 24 here and then 21 here. And if this 24 is coming here, then I need to take 20 here. And if 21 is coming here, then I need to take 17 here. So this is a complete matrix now. And let's check everything is working fine. Are we having the sum as 42 here? 4 plus 3, 7 plus 6, 13, 13 plus 22, 2, 4, 5, 6. Yes, this is 82, this is 82, right? 38 and 38, 44. Yes, everything is fine here. Let's look at this metric. Let's look at this matrix. What is wrong here in this case? Or is it working fine also? Let's see that. 20 plus 19 is 39 and we need the summation as equal to 82 now, right? So 20 plus, what are the numbers I'm left with? So 20 plus 19 is 39, 82 minus 39, 82 minus 39, subtract 40 and then add 1. 42 plus 1, 43. I need the summation here as 43. And what are the options that are left to me? The options left to me is 14 has been used, 15, 16, 17. 17 is available option, 18, 19. Okay, 17, 18, right? 19 has been used, 20, 21, 22, 23. 23 is available to me and 24 is available to me. I need the sum as 43. What are the two numbers which can give me the summation as 43 here? Okay. Yes, 17, 18, 23 and 24. Do we have the numbers with the summation as 43 here? 18, no, this cannot be equal to 43, this cannot be equal to 43, this cannot be equal to 43. So therefore this case is eliminated. You see that? There is no option which is left to me which can give me the summation as 43 here, right? 20 plus 19 is 39. 20 plus 19 is 39, right? And 82 minus 39 will be 43. I need the summation here as 43. The options available to me has been 13, 14, 15, 16. 17 is available, 18 is available, 19, 20, 21, 22 has been used, yes, 23 and 24. These are the only two options left. And none of these two values giving me the sum as 43. You see that? I need the summation as 43 here. So whatever options I'm left with, I need two such numbers where the E plus H should be equal to 43 and that is not possible here. 17 plus 18 is 35, 17 plus 23 is 40, 17 plus 24 is 41. So it's not possible for me to make the summation here as 82. So therefore this case is eliminated and this is my perfect case. So this is the complete matrix which is satisfying all the given condition here. This is the answer of the question, right? This is the answer of the question and this is how you're supposed to solve advanced level matrix set if you are coming across a set, right? Where not much information is given. Start making the probable cases, but think it logically, right? You need to try with those information, with that point which reduce down your cases, right? Which reduce down your cases to, from 4 to 3 or from 3 to 2. That makes it easy for you to solve, right? So you see that using this information, we reduce down our complete halls. We reduce down the set to the two possibilities, and then further this was eliminated, and this is the case that we are left with. That's it now. That's it, right? So this is the complete solution of the set. Thank you. You know how to solve the Sudoku, you will understand the concept straight away and will not take much time. All the 4 or 5 questions can be solved from this set in 4 to 5 minutes, right? It's just the understanding of the first paragraph. Your proper reading, your proper understanding of the first paragraph will help you in solving all the questions very easily. For example, here in this case, the information says you are given an n into n square matrix to be filled. N into n square matrix, you should know what is an n into n square matrix, right? We are supposed to fill it with numerals so that no two adjacent cells have the same numbers. And two cells are called adjacent if they touch each other horizontally, vertically or diagonally. So this is the main part that that you should try to make yourself understand. That what is the meaning of the word adjacent? If two cells are connected each other horizontally or vertically or diagonally, then they are called adjacent cell. For example, if I look at this particular cell, these three cells are the adjacent cell to this cell, right? If I look at this particular cell, this is vertically adjacent, this is also vertically adjacent to this cell is horizontally adjacent to this is diagonally adjacent to this, and this is also diagonally adjacent. So this particular cell has 5 adjacent cells. This corner cell have 3 adjacent cells, right? The cell which is exactly in the middle of this matrix will have 8 adjacent cells, right? So this is what has been mentioned in the first paragraph. Now the question is, what is the minimum number of different numerals needed to fill a 3 into 3 square matrix? You see that? If you don't try to make yourself understand what exactly is the meaning of the word adjacent, there is no point of solving the questions, right? It's only the small words, right? Whenever you're solving the NR set, it's very important that you pay attention to these type of words, right? Here the question says a minimum number of numerals, right? That means I need to use the minimum possible number of numerals to fill in this matrix. So whatever numerals, that means the numbers that I'm using to fill this 3 into 3 square matrix, those numbers has to be as minimum as possible, right? Pay this special attention to the word as minimum, sum, all, right? These are the playing numbers, right? Which you need to play special attention, which you need to give a special attention. If you don't give a special attention to these words, I guess you will never get to know what you are actually supposed to answer it, right? Question is very easy. You will get your answer in 1 second, right? Once you understand the information, right? So don't forget, in reasoning, most of the time it's your understanding and your attention to these small words, right? For example, if somebody simply read through this information and don't understand what exactly is the meaning of the word adjacent practically by taking the numbers here, that person will definitely make a mistake while answering the question, right? So make yourself understand the statement before you go to the answer. Question is very simple and straightforward, a simple question, right? See that I need to minimize the number of numerals. I need to minimize the number of numerals that is needed to fill a 3 into 3 square matrix. Now, if I want to minimize the number of numerals, right, I will try to fill a one single numeral at as many places as possible. And the condition is 2 adjacent cells should not have the same numeral. Okay. So whatever number you choose, whatever number, right? 1, 2, 3, 4, choose one number. Let's choose 1, right? Why 1? Because the question is not talking about which digit you are using. The question is about the numbers of digit that you are using to fill the matrix. So the numbers of digit is what you need to consider, right? Not that which digit you are using, that does not play any role here. Even if you want to use 15 here, you can use the 15 here, right? So if I'm using a one particular digit, let's say 1, and I want to minimize the number of numeral, I will try to use this numeral as many times as possible in this whole matrix. And the condition is 2 adjacent cells should not have the same numeral. Now, if I used 1 here, I cannot use 1 here, I cannot use 1 here, I cannot use 1 here. The reason I cannot use 1 in these 3 cells is because these 3 cells is adjacent to this cell. But do I have any condition that 1 cannot be used here? It can be used here. Why I'm using the same numerals here? Because I need to minimize the number of numerals. If I want to minimize the numeral, I need to use the same numeral as many times as possible, right? So if I cannot use in these 3 adjacent cells, I can use it here, right? Condition is not getting disturbed here. The condition that we are supposed to follow here in this particular question is not getting violated. So you can use 1 here. Also, now if 1 is used here, I cannot use 1 at these 3 adjacent cells. But can I use 1 here? Yes, I can use 1 here. Can I use 1 here? Yes, I can use 1 here. But these 3 adjacent cells cannot be used, right? Cannot be used with the same number 1. Once you use 1, these 3 adjacent cells cannot be used with 1 here. Now, can I use 1 at any other place? No, we cannot use 1 at any other place. That means now I have to go to a next digit, whichever digit you want to use, 2, 3, 4, 5, whatever, right? Let's pick the digit 2. Now, if I want to pick the digit 2 here, where should I fill it? Let's fill the 2 digit here. Can I use 2 here? No, I cannot use 2 here because it's vertically adjacent. Can I use 2 here? No, I cannot use it because they are diagonally adjacent. Can I use 2 here? No, because they are diagonally adjacent. So I'll the only place left in the whole matrix is to be used 2 here, right? Now they are not adjacent, so you can use 2 here. The next number, pick any number, write 3. Now let's fill the 3 at any place. Let's use 3 here. Can I place 3 here? No. But can I place 3 here? Yes, I can place it here, right? Now, is there any numeral out of these used numerals that you can use in this particular cell? No, because this cell is adjacent to all of these cells. So there has to be a different number that we have been using in all these cells. So that number will be 4. Now you see that. Now this 3 into 3 square matrix is completely filled. And now tell me how many numerals I used, how many numbers have been used to fill this 3 into 3 square matrix? 4 number. 1, 2, 3 and 4. So the answer to the question is 4. That's it. This is what they are asking, right? This is the question of CAT 2018, which is considered to be one of the difficult CAT paper, which you can see is not, right? The question is very easy. This type of set can be solved in 5 minutes, right? All 4 questions are based on the same concept, right? So this was the question number 1 of CAT 2018 slot. A basic knowledge of math, not even the basic knowledge, a basic understanding of the information helps you in solving this set, right? So all you need in LR is your confidence level and a proper reading of the information, a proper understanding of the instructions, and you are through with the set, right? In this video, I will be discussing question number 2 of CAT 2018 matrix based set. So in the first part, we discussed the instruction given in the first paragraph. The main instruction that we are supposed to follow as per the first paragraph is that no 2 adjacent cells should have a same numeral, right, while you are filling a matrix. And the meaning of the adjacent word is a cell, 2 cells are called adjacent if they touch each other horizontally, vertically or diagonally. For example, in this case, if I want to find out how many cells are adjacent to this cell, let's say this is cell number A. Now you see that if I look horizontally, the cell number B is adjacent to this cell. If I look vertically, cell number C and cell number D, right, they are adjacent to this cell. If I look diagonally, this cell number E as well as the cell number F is diagonally adjacent to this cell. So this particular cell have 1, 2, 3, 4, 5 adjacent cells. That's the only concept that you need to follow in this whole set, right? ये पूरा का पूरा set सिर्फ एक adjacent word की definition के ऊपर based है, and you can see that, right? What exactly is the level of CAT papers, right? CAT set बहुत छोटा सा concept है, एक ही point में question खत्म हो रहा है, right? सिर्फ अगर आप उसको ढंग से interpret करो तो आपके चारों के चारों question बहुत easily solve हो जाएंगे. Now what the question is asking me? The question is asking what is the minimum number of different numerals needed to fill a 5 into 5 square matrix? In the previous question we did how many numerals will be required to fill a 3 into 3 square matrix, but here we have 5 into 5 square matrix. That means we have 5 rows and we have 5 columns. So total number of cells are 5 into 5, that is 25. And we need to fill all these 25 cells with numerals, but those numerals has to be as minimum as possible. So same concept, exactly the similar concept that we follow in the first question, that if I want to minimize a number of numerals, right? If I want to use minimum numbers to fill this 5 into 5 square matrix, I need to use a particular number as many times as possible. For example, if I'm using the digit 1 here, now adjacent cell cannot have the same number. So if the adjacent cell cannot have the same number, this cell can be filled with 1. This cell can be filled with 1, right? I cannot fill 1 at these places, but I can fill 1 here, right? You're supposed to use 1 as many times as possible, because when you use a digit maximum possible number of times, the total number of digits that will be required to fill this 5 into 5 square matrix will get minimized, right? So can we use 1 in any cell in this second row? No. Why? Because these 2 cells are adjacent to these 2 cells, this particular cell. ये दोनों सेल इस सेल के साथ एडजेसेंट हैं, ये सेल इसके साथ एडजेसेंट है, तो 1 सेकंड रो में नहीं यूज हो सकता, बट थर्ड में तो यूज हो सकता है. सिमिलरली फोर्थ रो में 1 यूज नहीं हो पाएगा. आई कैन नॉट यूज 1 in the 4th row, but can I use it in the 5th row? Yes, I can use it in the 5th row. So I can use 1 here, 1 here, 1 here. Okay. Is there any possibility to use the same numeral again now? No, there is no possibility. Okay. Now that means I need to use the second digit now. What is that second digit? But again, the value of that second digit does not matter. The numbers of digit we are using to fill this matrix matters, right? This is what the question is talking about. So let's use a second digit number 2 now. I can use 2 here, I can use 2 here. Can I use 2 in these 2 cells? No, because all these 3 cells are adjacent to these 3. Can I use 2 here? No. So therefore let's use 2 here, let's use 2 here. Again 2 cannot be used here. Let's use 2 here, let's use 2 here. So 2 can be used in maximum of 6 cells, right? There is no other place left to use 2. If you use here, it will be adjacent to this, right? 2 adjacent cells should not have the same digit, okay? Now I need to pick one more number. So let's pick 3. Where can I place 3? I can place 3 here. Now if 3 is placed here, in this particular cell 3 cannot be used. Then I can use 3 here again. I can use 3 here again. Similar, following the similar pattern, you can see that 3 will be here, 3 will be here, and 3 will be here. 3 can be used again for maximum number of 6 times, right? 3 can be used for maximum number of 6 times. Now, is there any other possibility? Is there any cell available where I can use the number digit 3 again? No, I cannot use it because all the 4 vacant cell are adjacent to this cell where 3 has already been used. That means now I have to use a different number. Okay, if not 3 then 2. No, see that this particular cell, it is adjacent to all of these 3 9 cells. You see that? This particular cell is adjacent to all of these 9 cells. So none of that digit which have been used in these 8 cells can be used here. That digit will not be possible to use. So 1, 2 and 3 have been used in all these cells. So a new number need to be used here and that number will be 4. So I need to fill this cell with number 4. 4 यहाँ पे आएगा, फिर यहाँ पे आएगा, फिर यहाँ पे आएगा, and then 4 can be used here. So see that again the answer to the question is 4. The numerals that we are supposed to use, the minimum number of numerals, or you can say the minimum numbers that we are supposed to use to fill this 5 into 5 square matrix is 4. That is the answer of the question. This is the answer, right? A very simple question, free mark in CAT exam. Let's look at the question number 3. So the answer to this question is 4. Here is the question number 3, guys. Here is the question number 3. Now the question number 3 says that suppose you are allowed to make one mistake. Suppose you are allowed to make one mistake. That is, one pair of adjacent cell can have the numerals. What is the minimum number of different numerals required to fill a 5 into 5 square matrix? Question is good, right? But options are really senseless options, right? There's no point looking at the option. You can answer the question, right? Because the question is saying that now you are allowed to do one mistake. That means in 2 adjacent cell you can place the same number. Once you commit a mistake, you cannot repeat that mistake, right? Then you have to follow all the rules that have been given in the instruction part. Matrix is 5 into 5. Even the matrix has not been changed. We just saw in the previous question that a 5 into 5 square matrix can be filled completely with 4 digits. Minimum number of digits that are required to fill a 5 into 5 is 4. Now when I'm allowed to do a one mistake, when I'm allowed to make a mistake, my number of digits should get reduced. That means my answer for this particular question, if I am looking for the minimum number of numerals, that means the answer has to be less than my previous answer, or it can be at max equal to the answer, because now the examiner is allowing me to do one mistake. Doing one mistake means it is giving me the opportunity of using the less number of digits to fill this matrix. So my answer will be less than or equal to 4. All of the options, right? Look at the option number 1, look at the option number 2, and look at the option number 4. All these options are straight away eliminated, right? These 2 options are straight away eliminated. Straight away you can say answer cannot be less than, answer cannot be more than 4. The only option left is 3. Why answer cannot be more than 4? Because without committing a mistake, I was using 4 digit as a minimum number of digits, right? Now when the examiner is allowing me a one mistake to commit, that means that I might have 3 digits. I might require only 3 digits to 5 into 5 to fill 5 into 5 square matrix, or 2 or 1, but answer cannot go more than 4, right? Without mistakes allowed, without if If the mistakes are not allowed, the answer is 4. Now if the mistakes are allowed, how can answer be more than 4? So therefore straight away answer will be option number 3. Anyways, why? Let's look at theoretically also. See that we see that maximum number of times one can be used are at these places, right? 2 can be used over here. Now because it says one mistake is allowed, so if one mistake is allowed, that means even if I'm using a number 3 at these two cells, right, I will still require 3 here, right, to fill here. Now you see that I have committed an error. Now that error that I am committing here is allowed only once. I cannot commit that same error again now. I still have these numbers to fill, right? I still need to use a different digit out because now a mistake is not allowed. I still will require 4 to fill at these places, right? So therefore, minimum number of digits that are still required to fill a 5 into 5 into matrix is 4. Someone who understood the set and get the sense of the set can straight away answer this question in less than 5-6 seconds. The moment you read the question, you can straight away go with the option number 3 because mistake is allowed. The answer cannot go more than 4, right? These 3 are eliminated, so this is straight away the answer of the question. A very easy question, right? This is the last question of the set of n into n square matrix CAT 2018. The question says, suppose that all the cell adjacent to any particular cell must have different numeral. What is the minimum number of different numerals needed to fill a 5 into 5 square matrix? Question का meaning ये है कि 5 into 5 square matrix आपको fill करना है, but the new condition mentioned over here is adjacent cell में number same नहीं होना चाहिए. What is the meaning of it? Previous condition में क्या था? Previous condition में ये था कि किसी भी सेल के एडजेसेंट सेल में नंबर सेम नहीं होना चाहिए, राइट? फॉर एग्जांपल, इफ आई वाज यूजिंग 1 here, right? If I was using 1 here, right? If I was using 1 here, I was allowed to use 1 here, right? But this will not work in this particular case. Why? Because this cell as well as this cell are adjacent to this cell. Now adjacent cell of this one particular cell cannot have the same number. This is a new condition here, right? So this will not work in this particular question, right, which we have been following in the last 3 questions. As per the instruction given here, right, 2 adjacent cells should not have the same number. But here, 2 cells which are adjacent to the same cell should not have the same number. So there's a new condition here, and now the question is asking 5 into 5 square matrix को fill करने के लिए minimum कितने number of digits का requirement होगा. So कहाँ से question को शुरू करना पड़ेगा? You see that? If I have to see here, now you see that if I start from here, right, let's say if I'm using number 1 here, now how many cells are adjacent to this particular cell? इस cell के adjacent कितने cells हैं? 3 to 5 to 7 and 1. 8 are the adjacent cell, and I need 8 different digits to fill in these places to satisfy the condition of this question. तो 1 तो हमने यूज कर लिया और 8 सेल के लिए 8 डिफरेंट डिजिट यूज कर रहे हैं. सो लेट्स यूज 2, 3, 4, 5, 6, 7, 8 एंड 9. ओके, 9 तो हमें डेफिनेटली मिनिमम नंबर ऑफ डिजिट्स यूज करने पड़ेंगे. क्या और भी यूज करने पड़ेंगे? लेट्स चेक. नाउ लुक एट द नंबर 2 हियर. Look at the number 2 here. We have used 1 here, 3 here and 9 here, right? So I can use 4 here, right? 5 here, okay? 6 here, 7 here and 8 here. Okay. That means using the same numerals, the same digits which I have used in this particular, all these digits can also be used surrounding the cells of 2 where this condition is getting satisfied. All the cells adjacent to these cells are having different number. Okay, now let's look at this particular cell. We have 4 here and 1, 3, 5, 8 has been used, right? We have 6 here. So 6 must be as far as possible. Let's use 6 here, right? And 3, you see that the number 3 is here and 3 is having a cell adjacent. 3 is having 7 as an adjacent cell. So 7 cannot be used here. So 7 can be used here, okay? 4 is adjacent to this, right? 8 cannot be used here. 8 cannot be used here. 8 also cannot be used here. You see that? I cannot use the number 8 here. Because if I used 8 here, this particular cell have the same number in adjacent to this, right? So we have 1 here. What I am left with is 2, right? So I need to use the number 2 here, right? and the number 9 here, right? So 2 and 9 are left. So I use 2 here and 9 here, right? Okay, now everything is getting satisfied till now. Yes. Now let's try to see here. You see that 6 is being used here. 1, 2, 5, 7 has been used. What I'm left with is 3, 4, 6, 8. 6 has been used. 3, 4. 1, 2, 3, 4. 6, 7 has been used. 5, 6, 7, 3, 4, and 8 and 9. 3, 4, and 8 and 9 are supposed to be used. Now you see that 7 is here, right? 7 is having a cell adjacent to it as 8. So this cell cannot have 8, this cell cannot have 8, so I can use this 8 here, right? 7 is also having 9 here, I cannot use 9 here, I cannot use 9 here, so 9 has to be used here. What I am left with now is 7 is used, 9 is used, I am left with 3 and 4 now. And 3 or 4 can, 8 is having adjacent cell of 4, so 4 cannot be used here, so 4 has to be used here, so 3 has to be used here, right? All right. Now I have the number 8 here. 1, 3, 7, 4, 9 has been used. I'm left with 5, 6 and 2 to used. Okay, 4 is having 2 adjacent, so 2 cannot be used here, right? 4 के adjacent में already यहाँ पे 2 है, तो आप 2 को यहाँ नहीं use कर सकते. Okay, 2 को यहाँ पे use कर सकते हैं. Yes, we can use 2 here, right? No problem, right? And 2 has been used. Now we are left with 6. Can I use 6 here? No. 3 is having adjacent cell here, right? 3 के adjacent में already 6 use हो चुका है. So 3 के adjacent में 6 यहाँ use नहीं होगा. So I'll be using 6 here. Okay, what is left? 5. 5 is be used here. Now you see that 9 digits को अगर मैं use करूँ तो किसी भी cell के adjacent में same numerals नहीं है, right? So 1 के adjacent में 8 cell है, 8 के 8 different है, right? 7 के adjacent में 8 cells हैं, 8 के 8 numbers different है. 6 के adjacent में 5 cells हैं, 5 के 5 different है, right? So minimum number of numerals that are required to fill a 5 into 5 square matrix with the condition that adjacent cell will have different numbers. The minimum numbers are required. The minimum number required are as 9. So 9 is the answer of the question. That's it. So this is our question number 4. This is a bit tricky, right? You need to fill this complete matrix using the minimum number of digits so that no two adjacent cell have the different numbers, right? So condition को थोड़ा सा change किया, but question easy है. अगर आपको concept समझ में आ जाए, तो आप easily question को solve कर सकते हो. So you see that the purpose of discussing this set was to explain you the level of difficulty of CAT paper. It's mainly the selection of the set, right? I'm not saying that CAT do not ask डिफिकल्ट क्वेश्चंस आते हैं कैट के अंदर, राइट? बट क्या वो सिलेक्शंस के लिए यूजफुल होते हैं? नहीं होते, राइट? सो कीप योर सिलेक्शन राइट, इफ यू आर डूइंग द राइट सिलेक्शन ऑफ द सेट लाइक दिस कैन डेफिनेटली टेक यू to a good percentile. So it's very important that you select a right set, right, which you can solve in less than 5 minutes or 7 minutes. 5-7 मिनट के अंदर आपका एक सेट हो जाना चाहिए. तो अगर ऐसे सेट सेलेक्ट करोगे तो 5-7 मिनट में डेफिनेटली हो जाए. Quickly go through the instruction parts. Very important that you first understand the basic information here. It says 25 colored beads are to be arranged in a grid comprising of 5 rows and 5 columns. Each cell in the grid must contain exactly 1 bead. So you have to make a 5 into 5 grid, right? A kind of 5 into 5 matrix with 25 cells, and each grid need to have the beads with colored, right, with some colors, and those colors are not mentioned. Okay, now in the next line it is mentioned that each bead is colored either red, blue or green. While arranging the beads along any of the 5 rows or along any of the 5 columns, the rules given below are to be followed. What are those rules? 2 adjacent beads along the same row or column are always of different colors. So basically, by this time, right, you should get an idea. That you're supposed to arrange 3 colored beads, right? Red, green, and blue in a 5 into 5 matrix with these 3 conditions. This is what this whole set is about. It says, what are the conditions? 2 adjacent beads along the same row or column are always of different color. So if you make a 5 into 5 matrix, right, which is very easy to make, row wise or column wise, right? No two adjacent cell should have the beads of the same color. That means if I'm placing a bead of green color over here, I cannot place green color over here, right? 2 adjacent cell, row wise or column wise, should not have the same
colored bead, right? So if I'm placing green color here, I need to place green here. I cannot place green here. That's the first condition. And what does it says next? So green cannot come with green into adjacent cell, right? With 2 into adjacent cell. There is at least one green bead between any two blue beads along the same row or column. So between any two blue beads, right, you need to play one green bead, right? At least one. And this has to be at least one. You can place two also, but then those two cannot be in adjacent cell because green cannot come with green in adjacent cell. Third condition says there is at least one blue and at least one green, and the word here is and, right? Between any two red beads along the same row or column. So if I'm placing two red beads along the same row or column, I need to place at least one blue and at least one green. That means the difference between the two cells having two red beads will be at least two, right? Because I need to place one blue and one green. So one blue and one green should come between two red beads. These are the minimum possible beads, right? Now every unique complete arrangement of 25 beads is called a configuration. What does the question 1 says? The total number of possible configuration using beads of only two color is. What are the total number of possible configurations? So basically a unique arrangement of the beads in a 5 into 5 matrix is called as one configuration. How many possible configuration are there if I have to use only the beads of two color? Now, condition here is I cannot use more than two color. If more than two colors cannot be used, then you can clearly see that red cannot be combined with only blue. Why? Because between two red, I need one blue and one green. That means blue and green, both colors should be present between two reds. So can I say that it is not possible to make a configuration with red and blue and with red and green? The only possibility is to make the beads with blue and green. It's very easy and basic set. It's not difficult at all. I don't know why slot 2 DILR section is considered as the toughest DILR section, but it's not actually. These 4 questions are completely free. See that I can clearly see blue and green are the two beads color that I need to use to make the unique arrangements, the unique configuration with only two colors. Now blue and green. Okay, so if I'm placing two green here, or if I have to satisfy this condition between any two blue, I need at least one green. Okay, so let's use this. So if I'm placing green here, right? Then green here, because two blue cannot come together. Then can I place green here? No, two greens cannot come together. I need to place green here, green here, green here, right? Two adjacent cell cannot have the same color bead. So the only possibility for green would be this only, right? Okay, then I can place blue here, okay, and then blue here. Is it possible to place blue here? No, then blue and blue will become same, right? Then between these two green, I need to place blue. Between these two green, I need to place blue. Between these two green, I need to place blue. Between these two green, I need to place blue. Also here, between two green, I need to place one blue, right? Row wise and column wise, two green in adjacent cell cannot come together. This is the condition that you need to satisfy. So if I'm having blue here, is it possible to have blue here? No. Again, because two adjacent cell cannot have the same color, so I need to place green here. Then is it possible to place green here? No. It would be blue, then green, then blue. Again, if it is blue here, then I need to place green here, blue here, right? Green here and blue here. That's it. This is the one possible arrangement, right? So this is the one arrangement. Is there any other possible combination or any other unique configuration which is different from this configuration? Yes, we know that the unique configuration with two colors can only be made with a combination of green and blue. In this particular case, we started with green. What if I started with blue? Let's start with blue also. Is it possible to make a different configuration? Yes. If I place blue here exactly in a similar way, I can first place blue in all these columns to avoid having two adjacent cells same color. Then I need to place green here, right? So that two adjacent cells should not have the same color bead, right? the similar question to CAT 2017 set. In that question, in a 5 into 5 matrix, you were placing numbers with the conditions that no two adjacent cells should have the same number, right? And this is what we are doing here. The numbers has been replaced by colors, different beads colors. So in fact, this is even more easier than the one that came in CAT 2017. So if you would have done CAT 2017, in your practice, you must have done this set in slot 2 section, in slot 2 of DILR. Now between two green, I need one blue. Between two green, I need one blue because I cannot place same color. So you see that this one is a different from the one that we made earlier, starting with green here. So is there any other possibility? No. The only two configuration are possible, and that's the answer of the question, right? So the total number of possible configuration using beads of only two color, the answer to the question is 2. That's the answer to the question. A very easy question. Video. So I hope you go through that video first so that you get a basic idea what are the instructions here. But again, in this particular set, the instructions are not much. What you are doing is you have total 25 beads, right, of 3 colors, and these 3 colors are red, blue, and green. In a 5 into 5 matrix, you are supposed to place the beads with 3 conditions in the minds. And what are these 3 conditions? That 2 adjacent beads along the same row column are always of different colors. So 2 same color cannot be used. And at least 1 green between any 2 blue beads, right? So between any 2 blue, I need at least 1 green, right? And the third condition is 1 blue and at least 1 green, at least 1 blue and at least 1 green beads between any 2 red beads. So between any 2 red, I need at least 1 blue and at least 1 green, right? These are the 3 conditions that you're supposed to keep in mind. And the question number 2 says, what is the maximum possible, right? So keep this in mind, maximum possible number of red beads that can appear in any configuration. So whatever configuration that you want to make, you can make. But one thing that you need to keep in your mind is that the red beads should be as maximum as possible. I need to maximize the number of the red beads. Okay. So if I have to maximize the number of red beads, I will look at the condition number 3 first. Why? Because this is a condition which is talking about the red beads. What does it say? That between any 2 red beads, I need at least 1 green and 1 blue. And logically, if I use this information with this word maximum, maximizing the red beads mean I need to minimize the number of green and blue between the 2 reds. Why? Because in a 5 into 5 matrix, right? In a 5 into 5 matrix, the number of cells are limited. How many cells you have? The number of cells are 25. If the number of cells are limited and I want to maximize the number of red beads in a 5 into 5 matrix, I need to minimize the green and blue beads so that I can use red beads at maximum number of cells. Now, how will you do that? What are the conditions? 2 adjacent cells should not have the same colored bead. The second condition is between any 2 blue, there should be 1 green, right? Between any 2 blue, at least 1 green between any 2 blue beads, right? At least 1 green between any 2 blue beads, and between any 2 red, 1 green and 1 blue. All right. So now let's try to make a configuration of the maximum number of red. So what you have to do is keep this in mind. The conditions given here are applicable only row wise or column wise. It's not applicable diagonal wise, right? So now if I have to satisfy this condition row wise, and you see that I need to place red over here, right? I can place red over here also. Okay. Then at a gap of 2, I will be placing red here. And then column wise, I need to satisfy the condition. Row wise, again, I need to satisfy the condition. So I'll place red here. In row wise and column wise, am I left with any position where I can place the red bead? No. Row wise and column wise, I'm not left with any place because I need a gap of at least 2 cells between any 2 red beads. Okay. What else can happen? Can I place blue bead here? Okay. Where else I can place red? I cannot place here in these positions. But can I place red over here? Yes, I can place red here because the condition diagonal wise is not given. Diagonal wise, you can place the same color bead. And because I'm supposed to maximize the number of red beads, So I'll first place the red beads as many places as possible. So diagonal wise, I can place over here all these values. Also in this case, I can place a red here diagonal wise. Also in this case, I place a red here diagonal wise, right? Is there any other way left? No. Now a gap of 2 between the two red bead is not possible. These are the only cases that you can. Can I place red here in this diagonal? No. Then the column wise, these two red will be same, right? Now, I also need to make sure that between these two red, one green and one blue should be used. At least one green and one blue should be used. But then there's also a condition between any two blue, there has to be one green. So if I'm placing blue here, let's say if I'm placing blue here, let me use the color blue here, right? So if I'm placing the blue bead here, right? If I'm placing the blue bead here, I need to make sure I'm not placing blue here. Why? Because between any two blue, there should be one green. Between any two blue, there should be one green. So if I'm placing blue here, I cannot place blue here, right? Then where will I place blue? I will place blue here. Okay. And what will the, okay, blue is coming here, then I need to place green here. I'll write it down with the green color here. Okay, then, right. So I'm placing blue here, right? Can I place, okay, then next I can place blue here, right? All right, now the condition of blue and green, right? I need to place a green bead here, right? Between any two, right? Blue, I need a green here. Between any two blue, I need a green here, right? Now, what will happen here, right? What do I need to place over here? Between any two red, I need to place blue and green. Okay, now let's go ahead with this. What do we need to, where do we need to place blue here, right? Okay, so if I place blue here, let's say, then you see that automatically green will come over here, right? Then I need to place green here. Now, I also have these two as red. I need to place blue and green. In this case also, I need to place blue and green here also. Now, is it possible to place blue here? No, because two blue will be same. Then I can place only green. If I'm placing green here, can I place green here? No, then I need to place blue here. So if blue is coming here, then green will come over here, right? Okay. What else? Now let's, okay, if green is coming here, can I place green here? No, I need to place blue here, right? So in these two cells, I need to place a blue color bead. So blue will come over here, blue will come over here. Now between these two red, again I need blue and green. So blue is coming over here, right? I need to place a green color bead over here, right? Between these two red, I need blue and green, right? So blue is already there. So I need to place green here, all right? What else? So can I place blue here? Is it possible to place blue here? No. If I am having a blue color over here, then I cannot place blue here. Why? Because between any two blue, I need green. I have red here. So the only possibility here is to place a green color, right? So here I'll have a green color. What else I'm left with? This is the only cell I'm left with. Can I place blue here? This is blue. Between any two blue, I need green. If it is red here, then I need to use green color. That's the case now. This configuration is now completed. All you have to do is just keep those three conditions in the mind and keep on filling the information. That is not difficult at all, right? I have already told you this is exactly in the pattern of CAT 2017 matrix based set, which we have already covered. The video solution of that is also given in this on LRDA prep. So you see that what is the maximum number of times you have used red? Let's count it. 5 times on the diagonal wise, 2 times here, 7, and 2 times here, 9. 9 is the maximum number of cells where you can place the red bead. So 9 is the answer to the question. Question number 2. All right, we have the question number 3 of slot to DILR colored bead. Let's have a discussion on it. Hope you have seen the first 2 videos. Let's straight away go and see the solution of the question. Question number 3 says, what is the minimum number of blue beads in any configuration? See that it says it is a 5 into 5 matrix that we have, that we already know, and the number of colored beads that we can use is red, blue, and green. Now the important word here is minimizing the number of blue beads, right? Condition we know that between two blue there has to be at least one green. between two red, there has to be at least one green and blue, and then two adjacent cells should not have the same color bead. Now, our concentration should be on minimizing the blue bead. Now, it's fixed that total number of red plus green plus blue beads that we will be using will be 25 for sure, right? This is fixed. If I want to minimize it, right? Logically, you should be thinking, if I want to minimize it, I need to maximize the red and green, right? I need to maximize the red and maximize the number of green beads. Okay, then there are also some condition here that between two blue there has to be one green, and between two reds there has to be one green and blue. That means if I increase the number of red beads, right, I will be using, my two cells will be occupied, right? You see that? Logically, you see, total number of cells are 25, right? In a 5 into 5 matrix, total number of cells are 25. If I'm trying to use the maximum number of green beads, right? Between any two greens, I need to place blue, right? So that two adjacent should not be same. But then you see that maximizing the number of green beads will utilize three total beads, right? Because two greens will be occupied and one will be occupied with the blue. But if I use the maximum of the red beads, right? अगर मैं red beads को maximum number of time use करूँगा, तो मेरे total number of cells जो use होंगे वो 4 cell use होंगे. पूरे 25 cell में से इस combination के लिए 4 cell use होंगे, जिसमें blue एक ही बार आएगा, right? Then you need to think in this direction कि अगर इसको minimize करना है, then you need to maximize it. And which option should be the right one? Should I be maximizing the red ones or should I be maximum with the green one? You need to make the cases, to be honest, right? So let's try to make a case कि अगर मैं red को maximize करता हूँ, if I use the maximum number of red beads, then automatically the number of cells for this one particular arrangement used would be 4, right? Because I know कि between two reds एक green आएगा और एक blue आने वाला है, right? So 4 में से एक blue आने वाला है, right? So let's try to see कि इसमें क्या case बन सकते हैं. And we have already seen कि red को maximize करना है, तो previous question में हमने ये देखा था कि red को maximize करने के लिए आपको diagonal wise सारे red place करने हैं, because between any two reds, the condition of one blue and one green is applicable only the row wise and column wise. So अगर मैं सारे red place कर दूं, okay, then I can place red over here to maximize the number of red beads. Then row wise I can place red over here, okay, and then this row wise I can place red over here. Also column wise red is here, so I can place red over here. So this is the maximum number of times that you can use the red. Now between any two reds we need green and blue, so we have already made the combination. In this particular case, to do the complete arrangement, I need blue here and blue here, right? And I need blue here and blue here, right? We have already done this in the previous case. So then we'll have green here, green, right? Between any two reds we need blue and green, right? Right, so these are two reds, blue, green, right? Red. Then can I place blue here? No, blue and blue will be, cannot have red, you need to have green. So it's red here, it's blue here, so I can use green here only. So in this particular case, right, if I'm maximizing the usage of the number of red beads, the minimum number of times, the number of times I'm using the blue bead is 6. In this case, right, not in this case, red is maximized and blue is minimized, right? Red is maximized and blue is minimized. We have green, blue, and yes, this is right? So the minimum number of time blue bead is being used is 6, all right? Now, how will we get to know that this is the least possible number of beads that you can place, right? When it comes to a minimum number of blue beads. What if it try to maximize the number of green beads? In that case, you just have to make the cases. If that don't work, then this will be the answer, right? So now let's try to go ahead with the case. If I try to maximize the number of green beads, and the condition of maximizing the number of green beads is that you need to place at least one blue, okay? So I'm placing green here, right? Green here, right? Green here, right? Green. Between any two green, right? Okay, then again to satisfy this condition, to satisfy the condition that between any two blue, there should be one green at least, right? There should be at least one green. Let's also try to use maximum number of times red here. If I place red here, then the next red that can come over here, right? And then the next red can come over here, right? Okay, can I place red here? Yes, I can place red here. I can place red here, right? All right, so this is the maximum number of times you can use a red. Can I place red here? No, because between any two reds, I need green and blue. So in that case, it will be only green. So red cannot be placed here. Okay, can I place red here? No, between any two reds, we need green and blue both. Any other ways to place a red? No, right? So we have now maximized the number of green and the red color. Then is it possible to make a combinations now? Let's try to see. Then you see that here I'll be placing blue, right? Here I'll be placing blue here, right? But then here I cannot place blue. Okay, is it possible to place green here? Yes, I can place green here, right? For green, there is no condition that diagonal wise there is no condition. Okay, so try to maximize the green again. I can place green here also. So I can place blue here, right? Then again, I cannot place blue here, so I can use green here, right? Then this is green, I need to place blue here. All right. Now, you see that here, between two greens, I cannot place red here, so I need blue here. Between two greens, I cannot use red, so I need to place blue here. Between two greens, I cannot place red, so I can place blue here, right? Red and red cannot come together. And then this, again, I need to place blue, and this also I need to place blue. And you see that here, between two blue, we have green. But the problem is here, between two blue, we have red color here. So this red color cannot come. So this need to be replaced by green color, right? This has to be placed by green color. Now it will satisfy between two blue, we have green. Between two blue, we have green. Okay, just check it out that between any two blue, I'm having green. Yes, between any two blue, I'm having green. Okay, here there's no such case. Here, column wise, between two blue, I have green. Between two blue, I have green. I don't have two blues here. I don't have two blues here. Right. Okay, so here everything is getting satisfied. But what is the number of times you're using the blue color? Let's check it out. 1, 2, 3, 4, 5, and 6, and 7. Here you have 7 number of blues. So therefore, this cannot be the answer because as per the question statement, I'm supposed to find out the minimum number of blue beads, right? So we have taken the cases, right? In one case, I try to maximize the number of red beads and satisfy the condition and check the number of blue beads. In that case, the number of blue beads used were 6. And the another case, I tried to maximize the green beads and check the number of blue beads. In that case, the number of blue beads was 7. Because the question is asking me to find out the minimum number of blue beads, so therefore the answer to the question would be 6. The minimum number of blue beads would be 6. This would be the right answer of the question. Let's have a look at the puzzle here, guys. So what we have in this is, there's a matrix of 3 into 3 given here, and explanation is like this. The 3 pouches, each represented by a filled circle, are kept in each of the 9 slots in a 3 into 3 grid as shown in the figure. So we have a 3 into 3 grid, right? Column 1, column 2, column 3, row 1, row 2, and row 3, right? And we have, and in every cell, 3 pouches are kept, right? 3 pouches are kept. Every pouch has a certain number of 1 rupee coins, right? Each of the pouch has some number of 1 rupee coin. We don't know that number. And further it says the minimum and the maximum amount of money in rupees among the 3 pouches in each of the 9 slots are given in the table. Now there's another 3 into 3 table given to you, which represent the minimum and the maximum number of coins in a pouch in particular cell. For example, if I look at this row 1 and column 1 cell, now row 1 and column 1 cell is this one, and it says that the minimum number of coins kept in one of the pouches is 2 and the maximum number of coins kept in a pouch are 4. So you just need to straight away use this value, that in each of these 3 pouch, 1 coin has a minimum number of coins as 2 and the 1 coin has a maximum number of coins as 4. That means if this is a minimum and the maximum number of coins in pouches in this particular cell, what are the possibilities for this cell? Can I say that this pouch will be containing the number of coins which would be greater than equal to 2 and less than equal to 4? So I have 3 possibility for this. It can be 2, 3 or 4. This pouch can contain either 2 coins or 3 coins or 4 coins as per the definition here, because minimum are 2 and the maximum are 4. So this cannot go more than 4, cannot go below 2. So it has to be between 2 and 4, including 2 and 4 itself, because nowhere it's mentioned that the pouches cannot have the same number of coins. 2 pouches in a particular cell can also have same number of coins, because no such information is given that 2 pouches cannot contain the same number of coins. Okay. Moving forward, let's see that what else it's given as an example, right? How to read this table. You can easily go through it. Now, question says the 9 pouches in any of the 3 columns as well as in any of the 3 rows is it is known that the average amount of money in rupees kept in the 9 pouches in any column or in any row is an integer. So I have 9 pouches column wise, I have 9 pouches row wise. If I take the average of the total money of these 9 pouches, it should be an integer. That's the condition given here. Now guys, tell me, if I'm finding the total number of coins and finding the average of it, it has to be an integer. When I'm finding the average of the coins in the 9 pouches, I will be dividing it by 9 because the number of pouches are 9. Now, if I want average to be an integer, can I say the number here should be a multiple of 9? Only then the average will come out to be an integer. Now, that's a point that you need to solve this set on. Now, this is a basic concept. You have to look for those values where the numbers are supposed to be the multiple of 9. Also, it is given that the amount of money kept in the 3 pouches in the first column of the 3rd row. This is the first column of the 3rd row is rupees 4. And if you look at here, first column, 3rd row, the minimum number of coins are 1 and the maximum number of coins are 2. Minimum 1, maximum 2. So this particular coin, this particular pouch will have one coin because total it is given to be as 4. This complete cell contain 4 coins. This contain 1, this contain 2. So this will contain only 1 coin, right? So this is what we have here. Now let's fill in the value here. If you look at this, the minimum number of coins are 6, maximum is 8. This will be anywhere between 6 and 8. If you look at this value, this is 1, minimum 1, maximum 3. If you look at this, minimum 3 and the maximum 5. If you look at this, minimum 1, maximum 1. Now you see that the minimum is 1, maximum is also 1. That means this value cannot be anything else other than 1. So this has to be 1 only. If you look at this particular cell, minimum 6, maximum 20. Minimum 6, maximum 20. If you look at this 1, we have already filled this. This is 1, 2 again, minimum 1, maximum 2. This says minimum 2 and the maximum 5. All right. Now we have only one information to use, that the average should be a multiple of 9. Let's start from here. If you look at the number of coins here, 4 plus 2, 6, 6 plus 5, 11 plus 3, 14, 14 plus 4, 18. The number of coins that I already have in these pouches are 18, and I don't know the value in these 2 pouches. So what I should be adding to 18 so that it's become a multiple of 9? 18 plus something which is a multiple of 9, the number is next immediate number is 27. After that we have a number of 36. But then the values in both of these two has to be greater than equal to 2, less than equal to 4. And the value here in this particular pouch should be greater than equal to 3 and less than equal to 5. So the maximum value that you can take in the number of, in these 2 pouches in terms of number of coins is 9. So the only possibility to make the total of this as a multiple of 9 is to add 9 to the value, because the next number which is greater than 18 and multiple of 9 is 27. And to make it as a 27, I need to take the number of coins as 9 here. So now tell me what value I should be taking here if I want the total of these 2 values to be a summation of, to be having a summation of 9. Tell me what value I should be keeping over here. You see that the only possibility, because the maximum number of coins here you can put is 4. So 4 and 5 is the only way to go forward. Because if I put 4 coins here, 5 coins here, total will become 9, and that will become total, this will give me a total summation of 27 of these 9 pouches, which will be a multiple of 9, right? Look at this here now. We have 8 plus 6, 14, 14 plus 3, 17, 17 plus 3, 20 here, right? Now, what should I be adding to 20 to make it a multiple of 9? A number which is greater than 20 and a multiple of 9 is 27. So I need the summation of the coins in these 2 pouches to be equal to 7. Why not 36? Why can't we make it as a summation of 36? Because 36 is also a multiple of 9. You need to see that here. Maximum value of points that you can put over here is 8 and the maximum number of points that you can put over here is 2. So the maximum summation that you can get in these 2 cells is 10, right? So therefore, it's not possible to make a summation of 36 here. The only possibility is to make a summation of 7, so that this becomes 27 and the number of coins in these pouches becomes a multiple of 9. So now if I want the summation of these 2 cells to be 27, what should be the number of coins I should be keeping here? If I keep 7 here, I'll be keeping 0 here. No, that's not possible. I need more than 1 and less than 2 coins. So I'll be putting 6 coins here and 1 coin here. 6 plus 1 will become 7, right? Why not 5 here and 2 here? 5 is not possible because minimum is 6, maximum is 8. I need a value which is greater than equal to 6, less than equal to 8. The only possibility is to put 6 coin here and 1 coin here, right? No other will work. No other values will work. Okay, now this is a multiple of 9. Now if you look at this row wise, this is 4 plus 4, 8 plus 2, 10. 10 plus 6, 16 plus 6, 22 plus 8, 30, 30 plus 4, 34. Now tell me, what should I be adding to 34, which should be greater than equal to 1, less than equal to 33, so that it becomes a multiple of 9. A number which is greater than 34 and a multiple of 9 is 36. If I want this summation to be 36, I need a value 2 here. So I need to put 2 here. Why not 45? Why don't you take it as 45? Why can't I put 11? See that you need to look at the minimum and the maximum number of coins here, right? Now if you look at this column, this row, 5 plus 5, 10 plus 3, 13, 13 plus 3, 16, 16 plus 6, 22, 22 plus 20 would be 42. A number which is greater than 42 and a multiple of 9 can be 45 or it can be 54 also. For that I need a value of 12. It can be 63 also. For that I need a value of 21. Now tell me a number which is greater than equal to 6 and less than equal to 20 with these possible option. You see that 3 is not coming in this range, 21 is not coming in this range. The only possibility is to put 12 coins here, right? Now if you look at here, 3 plus 2, 5 plus 1, 6, 6 plus 6, 12, 12 plus 12, 24, 24 plus 20, 44, 44 plus 7 is 51. Now 44 plus 7 would be 51. Now tell me a number I should be putting over here that should be greater than equal to 2, less than equal to 5 and should be greater than 51, right? 6 plus 6, 12, 12, 24, 44, 49, 52, 51, right? Also if you look at the summation in this row, 4 plus 4, 8, 8 plus 10, 18. I need a number, 8 plus 7, 15. I need a number which I should be adding to both of these two values, should be making it a multiple of 9 and it should be in the range of 2 and 5. The only number possible is 3 because 51 plus 3 will also become 54 and 15 plus 3 will also become 18 and that will make it a multiple of 9. So you need to take this number as 3, right? Now the whole matrix is filled and you can answer all the questions, right? Now let's quickly go through the questions here now. Let's look at the question number 1. What is the total amount of money in rupees in the 3 pouches kept in the first column of the second row? First column of the second row. First column of the second row. There's a second row, first column. Total amount of money is 5 plus 5 plus 3. That is 13. So the answer to this question is 13. How many pouches contain exactly 1 coin? How many pouches contain exactly 1 coin? You see that this pouch contains 1 coin, all 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 1 7 plus 1 8, 3 to 5 6 7, 3 4 5 6 7 8. So total number of pouches which contain exactly one coins are 8. So the answer to the question is 8. What is the number of slot for which the average amount of its 3 pouches is an integer? What is the number of slots for which the average amount in rupees of its 3 pouches is an integer? So if I'm looking for the average of 3 pouches, the total should be a multiple of 3. This is having a total summation of 10. So this is not a multiple of 3. 6 plus 6 plus 8 is 20, not a multiple of 3. This you can see is a multiple of 3, right? This particular cell, right, is a multiple of 3. 3 plus 2 plus 1. This is a multiple of 3. 5, 5, 10, 13 is not a multiple of 3. 1, 1, 2, 3. This is a multiple of 3. 18 plus 20, 20, 48. This is a multiple of 3, right? 18, 8. Sorry, this is not a multiple of this. Total summation is coming out to be 38. 2 plus 1 plus 4. This is not a multiple of 3. This is not a multiple of 3. 5 plus 2, 7 plus 3, 10. This is not a multiple of 3. So only 2 cells. Summation of the number of points in only 2 cell is a multiple of 3. So the question says, what is the number of slots for which the average amount of its 3 pouches is an integer? The number of slots are 2. Only 2 such cells, or you can say 2 such slots. The number of slots for which the total amount of its 3 pouches strictly exceeds rupee 10. Strictly exceeds rupees 10. That means the number of coins should be more than 10, right? Now see that. More than 10. This is equal to 10. I should not be counting this. This is more than 10, right? 3 plus 2, 1. This is not more than 10. 5 plus, this is more than 10. This is not more than 10. This is more than 10, right? This is not more than 10. This is not more than 10. This is not more than 10. So how many such slots are there? Slot number 1, 2, 3. Only 3 such slots are there where the total amount of money exceeds rupees 10. So the answer is 3. These are the 4 questions of the set. You can see that set was comparatively very easy. It's not difficult. If you compare this set with the other sets of CAT 2019, this set is comparatively quite easy. And you just need to catch the one point, how to make the number as a multiple of 9. That's it. If you catch that point, you can fill this whole matrix quite easily. Must do set for everybody. This will give you an idea what kind of questions are coming in CAT exam. This is the set that we'll be discussing today. Let's have a look at the instructions first. Let's understand the basic instructions that have been given here, because most of the time whenever you're solving a logical reasoning set, main concept is actually hidden in the instruction itself. If you understand the instructions properly, if you read the instructions properly, 90% job is done. Let's understand it. In a square layout of size 5 into 5, 25 equal size square platform of different heights are built. So this is a layout of different platforms in a 5 into 5 matrix form. These are the 25 platforms, but each of these platforms are of different height. But the size is equal, right? The heights of the individual platform are as shown below. For example, you can see that the height of this platform is 6. Height of this platform is 1 meter. Height of this platform is 2 meter. Height of this platform is 4 meter, and so on. Now, individuals, all of the same height, are seated on these platforms. We say an individual A can reach an individual B if all the 3 following conditions are met. So individual people of same height are seated on these platforms, right? There are 25 people who are sitting on these 25 platforms. All these 25 people who are sitting on these platforms are of same heights, right? And a particular person sitting on a particular platform can reach an individual if all the following conditions are met. First condition is A and B are in the same row or column. For example, if I say one of the individual name is A and one of the individual name is B, and if A have to reach B, if A can reach B as an individual if and only if A and B are in the same row or column. Second condition that should be A is at lower height than B,
And third is, if there are any individuals between A and B, such individual must be at a height lower than that of A. What is the meaning of this statement? For example, if I want to check whether 5 will be able to reach 3 or not, first of all I need to see that 5 and 3 should be in the same row, same column, both are in the same row, and a particular person A can reach B only if the height of A is lower than the height of B. Now see that this platform height is 5 and it is more than 3, so 5 will not be able to reach 3. 5 will not be able to reach 3. But you see that 4 is at a lower height than 8 and both of them are in the same row, so I can say that 4 will be able to reach 8, right? And if you look at this, if I say 6 want to reach 1, a person sitting on 6 want to reach person sitting on the 1, both are in the same column, because 6 is at a higher height, 6 will not be able to reach 1. But 1 will be able to reach 6 because 1 is at a lower height as compared to 6. That's the whole concept. If you understand this part, you can solve this set very easily. And here, this is also an example how to read this whole matrix. Thus, in the table given above, you can see that it says, consider the individual seated at height 8 on third row. Height 8 on third row. So this is third row, this is a person 8. Now, third row and second column, he can be reached by 4 individual. He can be reached by individual on his left at a height of 7. So see that 8 can be reached by 7, yes, because 7 is at a lower height than 8. 8 can be reached by 4 because 4 is at a lower height as compared to 8. And also 8 can also be reached by 6 because the person between 6 and 8 is at a lower height as compared to 6. But you see that 8 cannot be reached by 5. The reason is between 5 and 8 we have 6, which is a higher height as compared to 5. 8 can be reached by 5 because 5 is lower at lower height as compared to 8. 8 cannot be reached by the 9 person sitting on the 9 number platform because 9 is higher height as at higher height as compared to 8. So see that 8 can be approached by these 4 individuals, right? Right. Rows in the layout are numbered from top to bottom and columns are numbered from left to right. So these are column number 1, column number 2, column number 3, column number 4, column number 5. Rows are numbered from top to bottom, row number 1, row number 2, row number 3. This is row number 4 and this is row number 5, right? Now, let's have a look at this question number 1 first. These are the instruction basic. Now, once you understand the basic instruction, you can solve the questions. How many individuals in this layout can be reached by just one individual? I'm supposed to find out number of individuals in this whole layout which can be just read by one individual only. Now, you see that if you look at the person sitting at 6, 6 cannot be reached by 1, cannot be reached by 2, right? Because someone who is approaching 6 must be at a lower height as compared to 6. So, sorry, 6 can be reached by 1, right? 6 can also be reached by 2. I'm looking for the individual who can be reached by just one individual. So 6 is not the part of the answer, right? So say, you can say that 6 would be eliminated. 6 is not the part of the answer, right? 6 is eliminated. Look at 1. You see that all the person who are surrounding 1 are at a higher height as compared to 1, right? So nobody will be able to approach 1 because 1 is at a lower height as compared to everybody else, right? So it's given that A can reach B only if A is at a lower height than B. So 2, 3, 5, 2, 5, 9 all are at a higher height as compared to 1. So 1 cannot be reached by anybody else. If you look at 2, you see that 2 will be approached by 2 cannot be approached by 3, right? 2 cannot be approached by 4. 2 can be approached by 1 only, right? You see that the first person 2 is a person which can be approached by one individual, that is 1, right? So this has to be the part of the answer. This is what we need to count, because 2 can be approached only by 1 on the left hand side. From the bottom, 3 cannot approach 2 because 3 is at a higher height, right? 4 also cannot approach it. So 2 is a part of the answer, right? If you look at 4 can be can be approached by 2, also can be approached by 3. So this is not supposed to be counted. If you look at 3 cannot be approached by 4. 3 cannot be approached by 8 also. So 3 cannot be approached by any of the individuals, right? because all the person was surrounding 3 are at in the same row or column at a higher height as compared to 3. So 3 cannot be counted. If you look at 9, 9 can be approached by 6 and 5 both. So eliminate it. I'm looking for those individuals which can be approached by one individual only. In this can be reached by just one individual. If you look at 5, 5 can be approached by 1 as well as 3, so eliminate it. 3 can be reached by 2 on the top 2 from the right, eliminate it. This particular 2 can be approached by none of the people, right? It cannot be approached by 3, 6, 8 and 4, so eliminate it. 8 can be approached by 2 and 3 both, so eliminate it. 7 can be approached by 3, right? 7 can be approached by 3, 7 cannot be approached by 8, 7 cannot be approached by 9. So 7 is an individual which is being approached only by one person, that is 3. So it has to be counted as a part of my answer. 8 can be approached by 7, 5, 4 both, all 3, so eliminate it. 4 can be approached by only 3. You can see that 4 can be approached by 3. 4 can also be approached by this 2 also, right? Because no, 4 cannot be approached by 2 because in between we have a person with a higher height as compared to 2. 4 you can see is approached only by 3. 4 cannot be approached by 6, 5, 8. So 4 is a part of the answer because it can, the person sitting on the 4 can be approached only by one person. 6 you can see that can be approached by 2, 4, 5, 1, all 4. 5 can be approached by 2 here, and 5 can also be approached by 9. So it can be approached by 2 individuals. If you look at 3, 3 can be approached only by 1. As you can see that 3 can be approached only by 1. So 3 has to be the part of the answer. We can the person sitting on 3 can only be approached by one individual. If you look at 9, person sitting at 9 cannot be can be approached by 7 as well as 5 both. So cannot be the answer. Person sitting at 5 can be approached by 4 as well as 1 both, so cannot be the part of the answer. 1, you can see that all persons surrounding 1 will be at a higher height as compared to 1, so 1 will not be approached, nobody will be able to approach 1. If you look at 2, 2 will be approached by 1 from this side and nobody else will be able to approach 2, so yes, 2 is approached only by one individual, that is 1, right? Alright. Now if you look at this one, 1 cannot be approached by anybody. 7 can be approached by 1 as well as by 6, so eliminate it. 6 can be approached by 3 and 5 also, so eliminate it. And this 3 can be approached only by 1, right? Nobody else can approach it. And 6, you can see that 3 can also be approached by 6 because the person between 6 and 3 is 1 which is at a lower height as compared to 6, so eliminate it. And then you have 9, you see that 9 can be approached by 2 and 3 both, so this will also be eliminated, right? I'm looking for those individuals which can be reached by just one individual. So how many person are there? Let's check it now. The number of people who can be approached by just one individual. So one person is 2, right? 1, 2, 3, 4 and 5, right? So these are the 5 peoples which can be approached by one individual only. So answer to the question is option number 2. That's the correct answer to the question. So if you understand the basic logic behind the set, you can easily solve the set, right? Look at the question number 2. We have already covered question number 1 in the previous video, so I'll be discussing the question number 2 here, right? The basics here is that all of these 5 in the 5 into 5 matrix form, we have the platforms of different height and all individual of same height are present on this platform. And one particular person A can reach another particular person B sitting on a different platform with 3 conditions. Both of them should be in the same row or column. And the height of A, right? If A want to approach B, A should be at a lower height as compared to B, right? For example here, 5 cannot reach 1. The reason is 5 is at a higher height at 1. However, 1 can definitely reach 5. 5 cannot reach 1, but 1 can reach 5, right? And if there is any particular individual between A and B, the height of that person should be less than A if A want to approach B. For example, if 4 want to approach 7, it's not possible because the height of the person between 4 and 7, that is 8, is more than 4. But if you see that 2 can approach 5 easily because the platform which is present between 5 and 2 is of lower height as compared to 2. So 2 can approach 5, but here 4 cannot approach 7, right? So based on this, right, based on these basic instruction, we are supposed to find out the answer to question number 2. It says which of the following is true for any individual at a platform of height 1 meter in this layout. If I'm looking for a person or individual who is present at 1 meter height platform, then you see that they can be reached by all the individual in their each row and column. No, you see that 6 cannot approach 1. The reason is 6 height is more than 1. As the given condition says, if A want to approach B, the height of A should be lower than B, right? 5 cannot reach 1 because 5 is at a higher height as compared to 1. 2 cannot approach 1. So see that in the same row or column, 1 cannot be approached by any individual. So this cannot be the part of the answer. They can be reached at least 4 individual. No, they can be reached at least, this eliminated. They cannot be reached by anyone. That's correct statement, right? This is option number 4. They cannot be reached by anyone, right? The person sitting at 1, because all the person who are surrounding the 1 are at a height which are higher than 1, right? So all of these people will not be able to approach the person sitting on the platform number 1. So the answer to the question is option 4. Let's look at the question number 3. We can find 2 individuals who cannot be reached by anyone in. We can find 2 individuals who cannot be reached by anyone in last row, fourth column or middle column. So I'm looking for 2 individuals either in one row or in one column which cannot be reached by anyone. If you look at the last row, this is the last row, right? You see that 1 cannot be approached by anyone, so this is a 1 individual. 7 can be approached by 6. 6 can be approached by 3, so this cannot be the part of answer. 3 here can be approached by 1, right? 9 here can be approached by all of these 3 people, right? So in the last row we do not have 2 individuals, so this is eliminated. If you look at the 4th row, this is row 1, row 2, row 3, and this is our row 4. In row number 4, you see that 3 can approach 9, right? Or if you look at 3 here, 3 can be approached by 1, right? So it can be approached only by 1 individual. I'm looking for that person who can be approached by 2 individual. Look at 9. 9 you can see can be approached by 9. 7 can be approached by 5, can be approached by 8, can be approached by 3. So this cannot be the answer, right? If you look at 5, 5 can be approached by 1, 5 can be approached by 4. So these are 1 person who can be approached by 2 individuals. 1 cannot be approached by any individual. 2, you can see that can be approached here by 1 only. So there's only 1 person who can approach 1. 2 can be approached by 1, and 2 can also be approached by 5, because 5 is at a lower. 2 can also be approached by 9. So this person too can be, the person sitting on this platform can be approached by 3 individuals, 1, 5 and 9, all 3. I'm looking for 2 individuals. We can 2 individuals who cannot be reached by anyone. I'm looking for 2 individuals who cannot be reached by anyone. And with the previous question we have seen that one cannot be approached by anyone, but I'm looking for, so this cannot be the answer. Look at the 4th column. If you look at the 4th column here, right? There's a column number 1, column number 2, column number 3, column number 4. Look at the 4th column. So 1 is an individual which cannot be approached by anybody. So there's a one person. And you see that 3 here can be approached by 1. So if you look at 6 here, 6 can be approached by 5. If you look at 2 here, 2 cannot be approached by 3 here. 2 cannot be approached by 8. 2 cannot be approached by 6. 2 cannot be approached by 4. So see that in the 4th column, I have 2 individuals sitting on platform number 1 and sitting on platform number 2. These are the 2 individuals which cannot be approached by anybody. So 2 individuals who cannot be approached by anyone are present in the 4th column. So 3rd option will be the correct answer of the question. Now let's look at question number 4. Which of the following statement is true about this layout? Each row has an individual who can be reached by 5 or more individuals. Now we have to go with the options only. Each row has an individual who can be reached by 5 or more individuals. Let's check. 1 cannot be approached by anybody. 5 obviously cannot be approached by 5 or more individuals. 2, you see that can be approached by 3, 4, no, 2 cannot be approached by 3, 2 cannot be approached by 4, 2 can only be approached by 1, so eliminate it. I'm looking for the individual which can be approached by 5 or more. 4, you see that can be approached by 2, can be approached by 6, can be approached by 3, can be approached by 2. It can be approached by 4 individuals, right? Not 5, so eliminate it. 3, you see that it's approached by 8 only, that's it. 3 can only be approached by 8. So row number 1 does not have an individual who can be approached by 5. So this statement is wrong, that each row has an individual who can be reached by 5 or more, right? So first option is straight away eliminated. Look at option number 2. Each row has an individual who cannot be reached by anyone. In the row number 1, I have 1 who cannot be reached by anyone. In row number 2, I have 2 who cannot be approached by anyone. If you look at row number 3, you see that 5 here can be approached by 8, 6 here can be approached by 5, 4 here can be approached by 3, 8 here can be approached by 5, 7 here can be approached by 3 and 9 both. So each row has an individual who cannot be reached by anyone is a wrong statement. Each row has at least 2 individuals who can be reached by equal number of individuals. Let's check this part now. So first and 2 we have already proved as wrong, right? First option is wrong, second option is wrong. Each row has at least 2 individuals who can be reached by equal number of individuals. Let's check it. Now this will take a lot of time, right? Instead of checking this option, let's check the option number 4. All individual at the height of 9 meter. All individual at the height of 9 meter can be reached by at least 5 individuals. You see that a person sitting at 9, you see that all the people who are surrounding here will be at a lesser height as compared to 9. So if A want to approach B, A should be at a lesser height than B. So 9 can be approached by 5, 9 can be approached by 3, 9 cannot be approached by 3, 9 can be approached by 7 here, 9 can be approached by 6. But you see that this person who is sitting at 9, right? This person who is sitting at 9 here can be approached by 5 only, can be approached by 6, and can be approached by 3. There are only 3 individuals who can approach 9. And the fourth says, person sitting at 9 can be reached by at least 5 individuals. That's wrong. It's approached only by 3 individuals. So fourth is also wrong, second is also wrong, first is also wrong. So option number 3 is the correct answer to the question. Each row has at least 2 individuals who can be reached by an equal number of individuals. You don't need to verify this because we have proved 1, 2 and 4 wrong. Straight away you can go ahead with the third option, because if I want to prove the third option, I'll have to look at each and every row and then prove it and then verify it that each row has at least 2 individuals who can be reached by an equal number of individuals. It's a complex exercise to do, right? So instead of proving 3 as true statement, prove 1, 2nd and 4 as wrong. That will be easiest way to do the question like this.
Learning in this set. Let's have a look at it. Let's read the direction first. It says, a farmer had a rectangular land containing 205 trees. He distributed that land among his 4 daughters, Abha, Bina, Chitra, Dipti, by dividing the land into 12 plots along 3 rows X, Y, Z and 4 columns 1, 2, 3, 4 as shown in the figure. So guys, we have this matrix here. This is the complete plot which has been divided into 3 rows and 4 columns. So that means there are total 12 plots, and all of these 12 plots contain 205 trees. It has been divided into rows and columns. So this is row number X, column number 1. This is row number X, column number 2, and so on. Some of these values are mentioned here. A represent the name of the daughter starting with A, that is Abha. C is the name of the daughter starting with the C, that is Chitra. So that means this plot contains 12 trees. This plot has been assigned to Abha, which contains 21 trees. This place is assigned to Bina, but we don't have the number of trees here. No mention of number of trees here. This is assigned to Abha. We have the number of trees here, but not the name. And all these values are missing. Now, with these instructions that have been given over here, you are supposed to fill in this whole matrix. Now, let's see that what does this information says. It says the plots in row X, Y, and Z contain mango, teak, and pine trees respectively. So that means row X contains row X contain mango trees, right? Y contain teak trees and Z contain pine trees. Each plot had trees in non-zero multiple of 3 or 4. Non-zero multiples of 3 or 4. And none of the plots had the same number of trees. That's the point here, guys, that you need to note down. None of the plot had the same number of trees. That means no value can reappear at any of these plot. Also, every number that should be coming in this whole plot must be the multiple of either 3 or 4. It should be a non-zero number. For example, here you can see that this number is a multiple of 3, this is also a multiple of 3, this number is a multiple of 4, this is 3. All the values that you're supposed to fill in over here are supposed to be the multiple of 3, right? Or 4. Okay, now let's read further. If in the figure the number mentioned in the top left corner of a plot is a number of trees, and there's a number of trees in that plot, while the letter in the bottom right corner is the first letter of the name of the daughter. For example, this is for Bina, this is for Chitra, and so on, as I already explained to you. Now, that's it. Now these are the points that you need to note down, right? These are the points that you have to use to fill this whole matrix. Now, let's use one by one all of these statements, and if you go with the right interpretation of these statements, you can easily fill this whole matrix. It's a pure quantitative reasoning type of LR set. Now look at the first information. It says Abha got 12 trees more than Chitra but 6 trees less than Dipti. Okay, it's about the number of trees that Abha got, right? Abha is getting 20 trees more than Chitra. Okay, so the number of trees with Abha is 20 more than Chitra, but it is 6 trees less than Dipti. So Abha's number of trees are 6 less than Dipti. So that's how A, C and D are connected with each other in terms of number of trees. We'll use this information later because right now we don't know what are the number of trees with Abha and all, right? The largest number of trees in a plot was 32, but it was not with Abha. This is a maximum value in terms of number of tree that you can assign in any plot to any person, and it is not with Abha. So firstly, Abha is not having 32 number of plot, and maximum value of trees in any of this plot is equal to 32. Simple information, right? Third statement says the number of teak trees in column 3 was double of that in column 2. Number of teak trees in column 3 was double of that in column 2. So if I say that this value is x, this value will be double of it, 2x. But was half of that in column 4. Now this value is half of this in column 4. That means this has to be 4x. Okay. All right. Now you see that, guys. If I have to use this information, that this number has to be double, and I know that the value of x can be either 3 or it can be 4, right? Because we need to put the values as a multiple of 3 or 4. Let's take the cases now. Let's take, if I'm saying that x is, let's say 3. If I'm taking this as 3, this will be 6 and this will be 12. And there's a statement mentioned over here that you cannot assign the same number of trees to any plot. Now, if you're mentioning 12 here, 12 has already appeared here, so 12 cannot come here. So 3, 6, 12 is eliminated, right? This is not a possible case. Okay. If not 3, then what about 6? 6 is also multiple of 3. If I put 6 here, this will be 12, this will be 24. Again, 12 is coming here, 12 is already there. We cannot use 12 again. So this case again is eliminated. Okay. What about the next case? Why not 9, 18 and 36? Next multiple of 3. You see that the maximum number of plot as mentioned in this particular statement is 32. No values can be more than 32. If I'm putting this as 9 with a third multiple of 3, this value is coming out to be 36. That's not possible. So can I say that the values which are coming in these 3 cells are definitely not a multiple of 3? If they are not a multiple of 3, then it must be the multiple of 4. So if I'm taking this value as 4, this has to be, if I'm taking this value as 4, this has to be 8, this has to be 16. Okay. Why not 8? If I take this value as 8, this will be 16, this will be 32. Now, this plot will have 32 plots, 32 trees, and that plot has been assigned to Abha. It is given that Abha is not having any plot which is having 32 number of trees. So 8, 16, 32 is also eliminated. Putting more than 8 in this will take this value more than 32. That's not possible. So the only case left is putting 4 number trees here, 8 here and 16 here. So let's use this information now. 4, 8 and 16. That's the number of trees that we got in these plot. This plot will have 4, this plot will have 8, this plot will have 16. Now we get to know how many plots are there, how many trees are there in this. Total number of trees in Y is 21 plus 4, 25, 25 plus 8 would be 33, 33 plus 16 would be 49. So this is having 49 number of trees in total. And the total number of trees that I have is 105, right? Total number of trees that I have is, as per the question, 205. Now, if this total number of trees are 205, out of it 49 are here. So I'll be left with 160, 156 more number of trees, which will be coming in row number X and Z. Okay, let's use further. Let's use some more information here. Okay, so we have used information till 3, right? Both Abha and Bina got a higher number of plots than Dipti. That's about the number of trees that Abha and Bina got. We'll be using this information later, right? We need a point which can help us in filling the whole tree in terms, whole matrix in terms of number of trees. So only Bina, Chitra and Dipti got corner plots. So B, C and D can corner plots. That means A cannot come in the corner. A cannot come in the corner, right? Only B, C, D will be coming in the corner, okay? Dipti got 2 adjoining plots in the same row. Dipti is getting 2 adjoining plots in the same row. So that means Dipti can get these 2 plots, or Dipti can get these 2 plots, or Dipti can get these 2 plots. 2 plots have been assigned to Dipti and both are in the same row. Bina was the only one. Bina was the only one who got a plot in each row and each column. Okay, so Bina is supposed to be present in each of these rows as well as in each of these columns. So Bina is having a plot in each of the row as well as in each of the column. Again, a point that cannot help us in finding out the number of trees at this point of time. Chitra and Dipti did not get plots which were adjacent to each other. Now, Chitra and Dipti are not getting the plots which are adjacent to each other either in row or column or diagonal. Now, you can use this information that I need to assign 2 plots to Dipti in same row, say in 2 adjacent rows, but C and D are not adjacent, row wise, column wise or diagonal wise. So if C is there, D cannot come here. If C is here, D cannot come here. C is here, D cannot come here. So I'm also supposed to assign a corner plot to Dipti as per the statement mentioned over here that B, C, D are getting the corner plots. So can I say that if I want to assign 2 plots in the same row, in the adjacent and 2 adjacent plots in the same row, this is the only option left with me. Can I say these 2 plots must belong to Dipti? And because Bina is present in every row and column as per the statement that we have just read, can I say Bina will definitely come here for sure? Bina is supposed to be present in every row and column. And you also see that Bina is here, Bina is here. In this column, we don't have, at this point of time, we don't have where the Bina will be because Bina can here or Bina can also be here. But I need Bina in this column also. This plot is already assigned to D, this is already assigned to A. So can I say Bina will definitely be coming over here because Bina is having a plot in each row and in each column. So this plot must belong to Bina, right? Okay. All right. Chitra and Dipti did not get plots. Okay, we have read this. The number of mango trees was double the number of teak trees. That's the main point here. Number of mango trees are double of the number of teak trees. So can I say that this value will be 98? Now the total number of plots are 205, 98 here, 49 here. The total is 9 plus 8, 17, 9 plus 4, 13 plus 1, 14. So the number of plots left for Z row, which are the pine trees, will be 15 minus 7, 8, 9 minus 4, 5. These numbers of plot will definitely be 58. The number of plots in this particular row will be 58. Okay. All right. So that's the information that we have. Abha got 20 more trees than Chitra. Okay, we don't know what Chitra is getting. Abha is getting 6 less floors than Dipti. Okay, we are supposed to use these two information. We have not used this information yet. So we'll be using it later, right? And the largest number of trees, we have used this. The number of teak trees in column 3, we have used this information. Both Abha and Bina got a higher number of plots than Dipti. Okay, both Abha and Bina got a higher number of plots than Dipti. So Abha must be getting more number of plots than Dipti, and we know that Dipti has got these two plots. So Abha must be coming at any of these 3 regions, right? One of these 3 regions will definitely belong to Abha. And also B will definitely be coming at any of these 2 places. Now C has got 2 plots till now. Okay. Right. So what's the next point that we need to use? What we can do here is, I know that there is one plot which is definitely having the maximum number of trees, and that is 32. Now, is it possible that any of these 2 will have 32 number of plot? Okay, let's see that. This total number of trees are 58 here, right? These can I say that these 2 values will definitely be equal to 58. Now, what are the possible combination of having 58 here? If any of this column is having, let's say, 32 number of plot, then the another plot will be having 26, 6 plus 2, 8, 3 plus 2, 5. Okay, that's a possibility. We cannot say this for sure, right? 32 and 26 is just a possibility. Okay. Now, if I have to divide B and C, there must be some information that we have to use here. Abha is getting 20 more plots than Chitra, and Abha is getting 6 less plots than Dipti. All right. All right. So, all right. So, guys, yes, there's a point here we can use, that if I'm taking a value of 32 here, right? I have missed one information, right? So that's a point here that you all need to take care, that every number that I'm putting in any of these cell must be a multiple of 3 and 4. We have not used this information. If I'm saying that any of these 2 cell is having 32 plot, then the second one will definitely be having 26. Now, this number is neither a multiple of 3 nor a multiple of 4. So can I say that 32 as a value cannot come at any of these 2 places? If 32 is not coming at any of these 2 cells, 32 must be coming at any of these 3 cells for sure, right? Now, the total value I'm supposed to put over here is 98. And one of these 3 cells will definitely be, out of this we have 12 here, 98 minus 12 will give us 86 trees. And out of these 86 trees, one of the plot will definitely have 32. So I'll be left with 54. Now I need to take 2 numbers. I need to take 2 such numbers which are the multiple of, we need to divide 54 in such a way that both of the values are the multiple of either 3 or 4. One thing is for sure, that one of these plot will definitely be having 32, right? 32 can come at any of these 3 cells. Right. Now, what are the other possibilities here? The rest of the 2 values summation would be 54. Now, if I say that 2 value sum, let's say A and B is equal to 54, and both of these 2 value is a multiple of either 3 or 4. What are the possibility? And none of the value can be more than 32. So, less than 32, the next multiple of 3 is 30. The highest multiple of 3, just less than 32, is 30. If I'm taking this value as 30, this value has to be 24. And if I go further, 29 is not a multiple of 3 or 4, then I can take this as 28, but 28 is already there, so I cannot use 28. 27 is a multiple of 3, but if I take 27 here, it has to be 27 plus 27. That means 2 plot will be having the same number of trees. That is also not possible. So this case is also eliminated. Then I'm left with again the only option that I'll be left with will be again 24 plus 30. Less than 27, 26 is not a multiple of 3, 25 is not a multiple of 3, and then you will come out with 24. We are already discussing a case of 24 and 30. So the rest of the two values in this will definitely be 24 or 30, right? So these three cells will be having the trees as 32, 30 and 24. But at this point of time, I do not know which cell will be having 32, which cell will be having 30, which cell will be having 24. But one of these cells is definitely made of 32, 30 or 24. All right. Okay. So that's the point here, right? And now we are left with B and C also. Similarly, if I have to make the cases for B and C, if I have to make a cases for B and C, the B and C total will be what? Let's see what should be the total of B and C. I have total 58 trees in this row. 28 plus 9 is 37. 58 minus 37 will be 21. Now, B and C summation is 21, and the possibility of 21 would be, with both values being multiple of 3 or 4, would be either 3 plus 18 or 15 plus 6. Further, if I go 12, 12 is already there, so I cannot go with the case of 12. If I take 9 here, this value has to be 12. Again, 12 cannot come here. Then further, the next case would be 6 and 15. So these are the two cases I'm left with, right? That these two cells will be either making a combination of 318 or 615. 3 can come over here, 18 can come over here, 18 can come over here, 3 can come over here, 6 can come here, 15 here, 15 here, or 6 here, right? Any of this combination is possible, but we do not know at this point which will be the possible combination. Okay, so we got this, right, information about the number of trees, how this whole, what will be the number of trees in each of these cells, but with some possibilities, still the unique value is not known to us. Okay, now let's use this information. If I'm using this information that A is getting 20 more plot than C, and A is getting 6 less plot than D. Okay. Now, again, D value is not known to us right now. So again, we cannot use it. Now, let's use further. Let's see that which information we have to use it. Both Abha and Bina got a higher number of plots than Dipti. Now, Abha is getting more plots than Dipti, and Bina is also getting more plot than Dipti. Okay. So if I'm saying that Dipti must be getting, right, either 24 plus 30 or 32 plus 30, again, the number of possibility, okay. Only Bina, Chitra and Dipti got corner plots. Okay, we have used this. Dipti got 2 adjoining, ye humne use kar liya. Bina was the only one who got a plot in each row and each column. Now, Bina is present in this column, Bina is present in this column, Bina is not present in this column. Bina is also not present in this row. So I need to make sure that Bina is present in this column as well as in this row. So you see that if I assign this plot to Bina, Bina's condition of being present in each row and in each column will get fulfilled. So we can say that this plot must belongs to Bina, right? All right. Chitra and Dipti did not get plot which were adjacent to each other. Okay. The number of mango trees was double. We have used this information. Okay. All right. Now this value cannot be assigned to D, right? This value cannot be assigned to C also. Why? Because it is given that C and D are not in adjacent row or column. So if I assign this to C, C and D will be adjacent, right? So B cannot come here, C cannot come here, D cannot come here. The only option left for me to assign this number, assign this plot is to give it to A, right? So this plot must belong to A. Okay. Now we still have one more option here. This value is still not assigned to anybody. Okay. Dipti got 2 adjoining plots. Okay. Bina was the only one. Bina was the only one who got the number of plots in each row and column. That means nobody else can be in each row or column, right? Okay, neither A at this point of time, C is here, C is here, C is not here, okay? Beena is supposed to be the only one who got a plot in each row and each column. Chitra and Dipti did not get plot, which only Beena, Chitra and Dipti got corner plots. Both Abhay and Beena got higher number of plots than Dipti. Higher number of plots than Dipti. I want the number of plots of A to be more than D. I want B also need to have more number of plots than D, right? Both Abhay and Beena got a higher number of plots than Dipti. At this point of time, you see that Dipti has got 2 plots, right? Dipti has got 2 plots. And Abha has got 3 plot. Beena has got 1, 2, 3, 4 plot. And C, Chitra has got 1 and 2 plot, right? So 4 plus 3, 7 plus 2, 9 plus 2, 11, right? We are left with one more plot. One more plot is supposed to be assigned. So which number has to be given? Each daughter, now you see that here, each daughter got an even number of plots. Now that's a point we missed, right? Each daughter got an even number of plot. So if I want to make Abha's number of plot to be even, one more plot need to be assigned to Abha, and that must be this plot, right? So now we got every information that which plot is given to which person, right? This must be given to A. Abha need to have 4 number of plots. So at this point of time, Abha have only 3 plots. So we need to make it 4. So therefore, this plot will be given to Abha, right? Now let's use the next information here. Now we are left with this information only, that Abha's number of plot is 20 more than C, and Abha's number of Abha's number of trees, not the number of plot. Abha's number of tree are 6 less than Dipti. All right, let's use this information from here. We can see that the number of plots with Abha at this point is 21 plus 4, 25, 25, 21, 9, 30, 30, 34, 34 plus 16 would be 50. So Abha has got 50 plots at this point of time. And Abha's number of trees, the number of trees with Abha's are 50, and which is 20 more than C. So can I say C must be getting 30? Now if C is getting 13, 12 is here. That means this plot must be having 18 number of trees. Now if this has 18 number of trees, then to make this as 18, I need to take a case of 3 and 18. So this will be having 3 trees, right? And then we got Abha is also getting 6 less than Dipti. So can I say Dipti must be having 50, Abha's number of trees are 6 less than Dipti. So Dipti must be having 56 tree. Now if I want to give 56 trees to Dipti, you see that which of these two values will give me a summation of 56, and that's only 32 and 24. So can I say that both of these two cells will be either 32 or 24, right? 32 or 24. So that the total can come out to be, for Dipti can come out to be 56. And this value you see for Beena would then definitely be 30, right? That's it. This is the whole set now. Now that we have filled the matrix, you can easily answer all the question. Let's have a look at the questions now. If I look at the first question, how many mango trees were there in total? Now, this was a question that you could have answered at the start of the set. You don't need to fill the whole matrix. This was just an exercise for you. The mango trees are 98. This we already know. So third option is the correct answer. This question had 6 questions in it. Which of the following is the correct sequence of trees received by Abha, Beena, and Chitra and Dipti in that order? Okay, we are supposed to find out the number of trees of Abha, Beena, Chitra, and Dipti. Abha, we have seen, is getting 50, right? So we have 50 with Abha. Dipti, we know, is 56. So 50 and 56. So this is the only option which have allotted 50 number of trees to Abha and 56 to Dipti. So straight away you can go with this option. A is the correct answer. How many pine trees did Chitra receive? Pine trees are, you can see, are in the third row, and Chitra is having 18 pine trees. So therefore the answer to the question will be second option. Who got the plot with the smallest number of trees, and how many did that plot have? Who got the plot with the smallest number of trees? The smallest number of trees plot. You see that the smallest number of trees plot is this plot, and B is getting that plot. And so the smallest number of plot had 3 trees, and that's given to B. So third option would be the correct answer. Which of the following statement is not true? Bina got 32 pine trees. Let's check. Bina got 32 pine trees. Bina got 32. No, Bina is getting 31 pine trees. 3 here and 28 here. I'm supposed to find out which of the following statement is not true. So yes, Bina got 32 pine trees is a wrong statement. That is a correct, that's not true statement, right? So this is correct answer. Which column had the highest number of trees? The highest number of trees you can see is 32, and we do not know that which column is this. Either it can be 3 or it can be 4. At this point of time, we don't have any information. Here we don't have any information which can help us in finding out that which of these two cells will be having 32 number of trees, right? So therefore the answer to this question will be cannot be determined. That is option 2. That's your whole set. It had 6 questions in CAT exam.